Oh, come on, Lisa. Shut up. This is ridiculous.
So, what have we got so far? Any brilliant ideas for the anniversary?
People, program, process, popcorn, and party.
Pole dance.
Professionalism.
We show people. Professional people.
Smiling people? No, please. Not just a parade of happy faces.
People,
Talking about where they're from.
No time for that. And how does that connect to additive manufacturing?
Right. Because they're holding something. A part. Cool design. Something 3D printed.
Let's hope your enthusiasm can save the pitch at 11. We'll need all of it.
Let's show the products. Think of commercials. For car porn style. This is gonna be hot.
Why not add some bad taste erotic music?
Let's not.
Yeah, let's not.
This project is killing me. It has to be something special.
Something special, something specific, specific industries.
Aviation aerospace? Lightweight is important to them. Engineering and construction? Definitely big ones in 3D printing. They'd love to see that too. And jewelry is on the rise. They sure expect more visitors from this sector. Don't even think about bringing up Paul.
But he was the secret star of the last exhibition.
Still can't believe it.
What about the faces behind Formnext, the organizing team? We have event management, sales and customer care, marketing and communication.
Exhibitor services, new sales, and the management. With Christoph, Sasha, and of course, Petra. Though I can already hear her say, I don't think this is gonna work that way.
Can we cover the entire process chain?
The entire process chain?
The entire process chain.
Epic film.
An epic film with huge machines and massive booths.
In slow motion.
Awesome.
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 That's literally every other trade show video.
Let's break expectations and we finally deliver something truly fresh. We show how AM works in production.
Done that already. Application Insight at Audi 2023.
Or we show the unique benefits of 3D printed parts made of special materials.
Done that already. Technical Ceramics, Exhibitor Focus 2024.
Or we dive into different 3D printing technologies.
SLS and SLA Technology, Exhibitor Spotlight 2022. Done that already.
Done that already.
Yeah, we do that every year. We need to nail this. We need to deliver something truly special.
So what do you suggest?
How about we finish with a conga line?
Oh, come on, Lisa. Shut up. This is ridiculous.
Woke up this morning, now watch me step. The week was murder. I'm gonna get rid of the stress. I'm feeling lighter. I'm finally feeling like I can breathe. The night is calling. Tension, gonna blow in the breeze. We're rolling downtown. We're grooving to the sound. We're rolling downtown. The weekend's here and it feels so right. I think I'll break the skins out tonight. I'm gonna go out and have a good time. Ain't nothing
It's day 3 here at Formnext, and Formnext News is back with the latest breakthroughs, insights, and highlights from the world's leading event for industrial 3D printing. Here are today's top stories. Spain brings a long-standing manufacturing tradition to Formnext, and this year it stands out more than ever. Many European countries are facing stagnation or even decline in industrial production.
And Spain, on the other hand, is growing. The manufacturing sector in Spain is growing, and which just shows how fast-paced and how innovative the sector is in Spain. And you can see that with the EM companies in Spain as well. There are new players entering the market. They are very application-focused, business case-focused, and you can see that here at Formnext as well. At the Adimat booth, for example, or IM3D Hub, our partners for the partner country this year.
To see how Spain's additive manufacturing sector is growing and which industries lead, we now hear from a Spanish expert sharing the latest insights.
The demand of additive manufacturing equipment has grown by 25%, and the demand of services has grown by 37%. And the main areas are defense, aerospace, and also car industry, and of course, health industry.
Formnext highlighted BAM, Built Environment Additive Manufacturing, connecting architects, engineers, and industry experts. Hall 11.0 featured 30 exhibits from top universities and companies, while the BAM Symposium brought researchers and practitioners together to spark collaboration across disciplines. Yesterday at Formnext, a live eyelid surgery demo took place at the Stratasys booth. Using advanced 3D printed models from Addion GmbH, surgeons practiced on realistic tissue replicas, building precision and confidence. Visitors are invited to stop by the booth to see the models and learn more about how 3D printing is transforming surgical training.
Formnext is all about the groovy stuff. Thank God we've encountered Lucas. Let's check him out. Hey Lucas.
Hello.
You have a company. What is that all about?
It's my startup. It's everything regarding prototyping. So if you don't have an idea and you need to have someone fulfilling it, I'm your man.
Okay, can you show us hands-on what you've got?
Let me get out. So up here we do have 3D printed parts to reinforce the roof rack, and all of it is printed down here. I got rid of the rear seat bench because I don't need it. I want to work from anywhere. So you do have Starlink on top here, a roof tent, and if you're my customer and you call me and I'm in the middle of nowhere, I'll do it.
You'll get it done.
Definitely.
AM makes dreams come true. Thank you so much.
Yeah, for Siemens Energy, Formnext is a key fair, and it's really a melting pot for all additive manufacturing technologies. And we are meeting vendors, we meet suppliers, and we meet also our customers where we deliver parts to.
So Formnext is very interesting for us because we use a lot of 3D printing in-house and also for our production parts. We use it in-house for product development and concept verification, also for testing. We use it, like I said, for our production parts as well. So it's good to see all the different capabilities of the printers here and the different materials, as well as like the 3D scanning aspect as well.
So we are focused mostly on the maritime sector, also motion tooling, research centers, universities, and on the additive construction side.
We want to see the newer materials that are released, also the new machineries. We are based with mostly polymer systems, but we are also looking very much now into metal powders and metal AM, which is very interesting for us.
I come to Formnext because I'm studying mechanical engineer, and it's very interesting to see everything about 3D printing.
And here are today's upcoming events. The industry stage on perspectives and challenges, the application stage on 3D printing and sustainability, and the technology stage on aerospace, defense, and new additive innovations. So be sure to check them out, and there's plenty more happening across the show. Additive manufacturing is booming, with startups, established companies, and young innovators driving fresh ideas. Whether you're starting your career or seeking new opportunities, visit the career area. Meet leading employers, network, and explore the latest jobs in industrial 3D printing. New this year at Formnext 2025, guided tours on post-processing. Today at 2 p.m., visitors can join a 1.5-hour tour through selected exhibitors to get quick insights into the latest products and innovations. The tour starts at Foyer Hall 12.0 West and ends at the International Sales Lounge. Spots are limited to 20, first come, first served. Join the excitement at the Formnext Awards. Online voting for your favorite finalists closes at noon today. 6 categories packed with breakthrough ideas in additive manufacturing, and the winners will be revealed at 4:20 p.m. on the industry stage. We wish you a great third day at Formnext and hope you gain many exciting insights into the world of additive manufacturing.
Celebrating 10 years of Formnext this year. The 11th has obviously already started. Make it safe, make it AM. Bye.
Since 2015, Adamat has been the heartbeat of Spain's additive manufacturing ecosystem, connecting people, technology, and purpose. Under the leadership of Nayara Zubizarreta, the association has united more than 100 members, from startups to global players, all the while shaping a vibrant AM community that now stands tall on the international stage. Through strategic collaborations, advocacy and European policy forums, and the creation of joint missions to Formnext, Adamat has transformed visibility into influence. Celebrating its 10th anniversary this year, Adamat embodies what true AM ambassadors do. That is, advance technology and build the communities that make progress possible. In Würzburg, SKZ, das Kunststoffzentrum, is bridging a crucial gap in the AM workforce. Together with the Chamber of Industry and Commerce, they've launched Germany's first certified industrial technician in additive manufacturing, a hands-on qualification with no academic barriers. This 2-year program combines theory and real-world application, from polymer and metal 3D printing to safety, design, and production management, empowering technicians to become true AM professionals. With 19 experts and a curriculum rooted in practical learning, SKZ is turning curiosity into competence and ensuring that the future of additive manufacturing is powered by skilled, ready talent. Innovation starts with education, and at RWTH Aachen University's DAP Institute, they're redefining how the next generation learns additive manufacturing. Through a pioneering, data-driven learning framework, the DAP team combines Industry 4.0 analytics, immersive AR and VR experiences, and real-time labor market intelligence to keep education aligned with industry needs. Students explore complex AM processes hands-on, from design for additive manufacturing to powder bed fusion, guided by simulations that bring invisible forces to life. By blending research, technology, and pedagogy, RWTH Aachen DAP is teaching AM and shaping the way future engineers think, learn, and lead in this industry.
Hello and good morning, ladies and gentlemen, and welcome back here on day 3 of Formnext 2025 here in Frankfurt. Welcome back to the industry stage. We are kicking off day 3 with our morning talk, and we have excellent guests here with us. We are mainly talking about technology over the last few days, and today we want to tackle a different topic. We want to talk about associations, organizations that drive the business in Europe and in Germany. And let me quickly introduce our guests. To my left, we have Philipp Gertz, who is heading and leading AM Europe, representing Sesimo as well, and driving the AM business in Europe. Then we have Carsten Häuser, who is a two-hat today. On the one side, you are responsible for the additive manufacturing activity at Siemens, but you are one of the key voices of Germany Makes initiative. Great to have you here, Carsten.
Thank you.
And last but not least, I don't need to introduce him, but I still do, Frank Jablonski, my co-moderator here today in the morning talk. Thanks for being with us, Frank.
Thank you, Sven. Thank you, Sven. You're looking fine as well.
Okay, thank you. So, Philip, let's kick off with you. Introduce us quickly. What is AM Europe standing for? What are you trying to achieve? Let us give us a short overview of the structure.
Okay. AM Europe wants to foster the dialogue between the additive manufacturing industry and the policymakers in order to have a unified and impactful, influential voice to shape the political and industrial landscape for additive manufacturing. So it's an open and collaborative network. It has been created by 10 national associations representing additive manufacturing sector, like VDMA in Germany, but we are representing France, Italy, Austria, Spain, to name a few, most of them. And it's still operated by Sesimo, the European Association for Manufacturing Technologies, because we do have this long-standing advocacy, legacy about also additive manufacturing in Brussels.
And one question, who was the driver in order to initiate it and start it?
So the driver was really that we wanted to put more light, more focus on additive manufacturing. Additive manufacturing is strategic for the competitiveness, sustainability, resilience in Europe, but it still does not get enough attention in the European industrial policy.
Yeah, very good. Carsten, that leads me to you. Taking a closer look at Germany, Germany Makes, what was the driver behind that, where you stand today? I mean, there happened already a few things, and what still needs to be done? That were a lot of questions, sorry, but...
So, in my Siemens business, I'm responsible for additive manufacturing worldwide, and I see a lot of different countries, and this is the purpose why we join forces here with Europe and with Germany. China has a national AM strategy for 10 years. Singapore has an additive strategy. India placed an additive strategy, how to develop India. America with America Makes. So what is the 10-year strategy of Germany? Nicely bound together with Europe level, there is no. And we have 16 states in Germany. We have great pioneers. A lot of leading companies invented and innovated additive, maybe in the supply chain, machines, software, and applications. And it's relevant as a key enabler for more than 10 industries. Now, it's nothing more that we are sitting together, VDMA, Mobility Goes Additive, plus 5 regional ecosystems, and we said, let's do one topic out of 5, 6, 7, and speak with one voice to the government. And then we have IM Hamburg from the northern region. We have Bavaria Makes from the state of Bavaria, and then we talk as one voice to the German government, and through the bridge of VDMA being part of our kind of virtual initiative, it's not a new association. It's bringing the regional activities in Germany into one basket, and then we are as well much more powerful to speak on European level, and you drive it across Europe with all the other, I think, 6, 7, and 8 associations from other countries. We need to have a 10-year roadmap for Europe, and we need to be stronger. Otherwise, we will fall behind in the next 5 years.
Yeah. So, sorry. So the goal is clear, I think, but I'm not so convinced about the path to that goal. Sesimo has a long experience in trying to get all the European countries, the machine building associations together and to have a to bind them together. What makes you think that it will work fast and good with additive manufacturing? There are you named them. There are so many small initiatives in Germany even, and looking at Europe, there are so many voices. I think it's very hard to collect them all and to give them one voice.
Yeah.
How do you do it?
I'm fine. I mean, we're all on the same speed, so there's no issue. And we all want the same objectives. And it's true, I think we still have additive manufacturing is still very good globally, global landscape in Europe. We are the home of world-renowned machine builders, of material developers, of research and innovation centers. But it's true, there is more and more competition coming from other regions because they have a strategy over there, like you said, American Make, Dynamic, etc. And they have more public and private investment and political coordination. So what we wanted to do, and the first thing that we did already with AM Europe, is we wrote a manifesto for the competitiveness of the European additive manufacturing sector. And over there, we are really asking the governments at all kinds of levels to have a coordinated strategy, a real dedicated strategy to this sector. And then also that it is part of global industrial strategies. And that's why it's so nice to have Sesimo also on board and the other national associations in the manufacturing sector, because we want to have more attention to advanced manufacturing in general in all kinds of policies at European level. Think about green policy, digital policy, roadmaps, technology roadmaps, etc., etc. So many things to do there. And the final objective is even to have a public-private partnership so that it will be a one-stop platform for industry, but mainly also for politicians to know about additive manufacturing. So we bring together research, deployment by the industry, and policy to support this. But we want to have a more dedicated strategy like we have in other regions of the world.
So Frank mentioned the fragmentation of the different initiatives, and Carsten, you just mentioned how Germany has built it up with a regional approach, getting in line on a German level with Germany Makes. So is this strategy you were talking about, Philipp, is that in line with the different levels below, so the European countries? Because this, as we experience Europe as a very, very strong union, so we have the EU, and then they are pushed by the single countries and the other way around. So is that strategy in line with the regional associations and initiatives?
Absolutely. I mean, everybody has to play where he's strong. And for example, we, with AM Europe, and then mainly because it's empowered by Sesimo, our unique selling point, I would say our real DNA is advocacy. So we are going to focus, and we are focusing on influencing the European strategy. But of course, if you want to know what's really happening in the market, you have to be close to the market. And that's where you have the national associations and regional initiatives. And I think we all just have to work together. We have to give the example at our authorities that they also have to work together. Yeah. And of course, what we see, many of these industrial-led initiatives, is that they want to bring together research institutes, authorities, and the industry.
So you mentioned your manifesto. Who worked on that manifesto, and is it a common agreement already?
Yeah. So the manifesto has been elaborated mainly by these 10 national associations in working groups. But straight from the beginning, we said we want to cover the whole ecosystem. It's very important to cover the value chain. That's why we have partnerships with many other associations, not only even in Europe, but globally. Like, for example, we have a memorandum of understanding with ASTM because they are strong in standards.
Absolutely.
Or, for example, in the workforce deployment, etc. We have, yesterday we signed a memorandum of understanding with the European Powder Metal Association because they are strong in materials. And we will have similar ones also with mobility, goes additive, etc. So, because everybody has its strengths and together.
So it's like organized in working groups or something, or where we can join when the audience says, okay, I want to work with you to build up that that ecosystem or that strategy.
See it as different levels. So if you're in one state in Germany, you should first go to your regional ecosystem.
Yeah.
Please don't call Philip from Garching or from Rosenheim. Go
why
with
not?
your regional ecosystem. The regional ecosystem is embedded with VDMA into the whole ecosystem, and we need to trust each other that then this is handed over. All the input needs to be shared across the states. And yes, sometimes it's as well about people. Do they want to share data, transparent? Do they want to collaborate? Do they trust each other?
Do they have the time?
So you have the job to keep it together on the European level, and we do our job to keep it working and transparent and collaborating on the national, even to the regional level. So Philip joined us in a regional conference we did in Munich with the Bavaria mates. And he could get this feedback back onto European level and then share it as well across with other countries. I think 7 or 8 countries signed the...
No, 10 or something. But for example, if I can add to that, a very good example is that just after this meeting, we have a European roundtable over here at Formnext. So we invited EU decision makers, people from the DG GROW. I mean, this is, of course, jargon of the Europe, but from the different departments who are working on industrial policy, on innovation, on skills. They come here. And also people from the European Defence Agency. So we explain them our concerns. And we explain them our technology. And we explain them mainly what are the applications that we can bring with additive manufacturing. And then we do a tour around the fairground to make them see what is happening in reality.
Feel and experience.
So that's our job, is there to bring those decision makers to here.
Carsten, I mean, you are not only reflecting the associations or initiatives, you're also reflecting a company that is earning money with additive manufacturing. So if you talk to politicians and taking into consideration your experience as Siemens representatives, what are the main needs that you are addressing when talking to politics? What are the main topics? Is it either funding? Is it rather skills? What are the topics?
The first topic is generate awareness.
Okay.
And make transparent what you would not be able to do if you lose the technology sovereignty of additive manufacturing. You would not build the next rocket, and we have a huge space industry in Europe. You would not be able to transform energy into hydrogen electrolyzer if we do not have the technology of additive manufacturing available. And you can go on medical products. You can go on automotive products, on mobility and other products. The question is for us as Europe, and I see more the country as Europe here, do we want to stay ahead as a technology innovation leader in a cross-horizontal enabling technology? And additive sometimes is complex because this is not the e-car, this is not one industry, it's an embedded enabler within the manufacturing. So the first topic was generate this awareness. There's a topic you need to put on the visibility of politicians. Yeah. Now is the time to react and to act. The second one is you need to orchestrate the whole thing. Yes, we as companies don't need the next research funding for basic research. You need to bring it now into the industry of applications. You need to build up production champions for these industries. And you need to combine this material, machine, software, AI will play a huge role in that. And this needs to be orchestrated. And orchestration is something where you need to have someone on national, but as well in close exchange on European level, how to orchestrate. One problem, pain point was, we get a call every month from several institutes. Hey, I want to do a research project on melt pool monitoring. Where I say, hey, there are 50 projects, probably 100 in Europe, focusing on exactly the same problem. If you then look to China or India, you see they bundle research topics. They overcritical bring together industry to really change the needle and bring it into application. And this is something we need to generate the transparency, we need to increase the awareness, and then we need to orchestrate and share data, knowledge, expertise among the industry, that we do not start to invent the wheel twice.
Yeah. Just one add, and it fits perfectly, I promise. So if Carsten talking about orchestration, as a typical German, I start being nervous because usually I know that it's a long process, especially in Europe with our regulation. How do you perceive the speed corresponding to what Carsten said? Are we able to keep up with China, US, India, you mentioned that, with their strong strategies?
Yeah, we are slow in Europe. Huh? Yeah. Nevertheless, there are good intentions.
No, that's not what I said.
No, absolutely. I fully, at the regulatory, not the industry, the regulatory issue, because we want to do it always too good. In any case, there is a big shift. There is the awareness that there is an urgency. We have had this Draghi report that things like, we have to do something. And there has this shift from green to more and more now competitiveness. Now people speak about competitiveness. But this is my point. Like, for example, Sesamo with the experience that we have over the years on how to do advocacy. We know if we want to speed up and get attention for the sector, we have to find links to what's important for them, what's on their agenda. And they want to have this green and digital transition. They want now resilience, autonomy. We have to use those themes and we have to show them where additive manufacturing can really bring a solution.
But let me give you one question. You said the German, you mentioned all the aspects were really, really clear and cool, but in the German government, nobody hears you, I think. We had the funding. We had the funding in the new government in combination with lightweight. Now there is no funding at all, so nobody hears you in our government at home.
That's not true. If you look what's happening, there has been a group on European level, I think 2 weeks ago from joining the alliance. There has been a group in the Ministry of Economics. There is a group working with VDMA and others on the high-tech agenda for Germany. The question is, because it's a horizontal topic, and currently we got the feedback we need to embed it into the industries and not as a separate topic. And this is something you see here as well at Formnext. We need to integrate additive as a native choice in the defense industry. So we need to look where the defense industry is coordinated. Then we need to look where the aerospace, aviation industry is coordinated, the medical. And there are, in the high-tech agenda of Germany, a lot of these topics, but sometimes it's hidden behind these industry topics. So what we need to make sure that we all know there's a lot of costs between the industries that we share among that. And yes, Germany, Europe, companies are able to still innovate. And this is, you see all over the place at Formnext this week. You just need to come and visit the Siemens booth. We have great examples how Bosch as an automotive tier 1 supplier, how exploration, how GKN they are really implementing additive as an advanced manufacturing step in a full workflow. And now AI is probably supercharging, accelerating the whole game, because this will make the transformation much easier in the future.
Yeah, but you're totally right. But if you want to have a strategy, you have to promote that strategy. You have to make it visible. Where is the strategy when you say, okay, AM is there in the government at several points, but where is it visible? A visible aspect would be 10% when the government makes some announcement or some investment somewhere, like Deutsche Bahn did it. So our suppliers like Siemens have to give us our trains with 10% additive manufactured parts. So that is a clear strategy. Everybody, that's one clear number. Everybody understands it, and everybody can act accordingly. And we need something from the government like this, in my personal view. We need something from the government as well. We need a clear message. We want to have additive in our defense area, for example. And so the defense companies, they have to work on additive as well. 10%, 5%, I don't know.
Yes, it's always difficult to say if government knows what the industry needs. I think they need to orchestrate it. And we have done this in Bavaria. We've developed as global industry there, 120 companies working on additive in Bavaria. We developed a 10-year roadmap for Bavaria. Yeah. This was now handed over into Berlin as a good example to develop now the 10-year roadmap for Germany. And there are these topics inside. And just take defense. The German Bundeswehr, they have huge programs deployed on additive manufacturing. They coordinate it as well. The same happens in the space area with the Deutsches Luft- und Raumfahrt, DLR. So a lot happens. However, we need to make sure to share knowledge among that. But I would doubt if it's a good idea if a government would make a demand for an exact decision. No. This is not what they are made for. They are good in bringing this together and forcing as well the different players to come together to form one initiative and one national roadmap. And yes, it's as well about then strategic funding of the next research topics by the industry with Fraunhofer universities and connected on the European level.
What I think Philip made a really good point. You said we have to focus on their interests, basically. Absolutely. So, and I think I'm with you, Carsten. I don't think it's something government should push. So we are there to fulfill the needs either of our clients or customers in the industry. We have to deliver services to the verticals, because if they need additive manufacturing, then it's self-driven. We all know that. And of course, we need to reflect in our industry, in our initiatives, in our strategies, what is needed over the next decade in terms of innovation, what are the topics we want to drive. You named a few. Yeah? So I think this is the absolute right way we are going. And I hope we are fast enough, because I think on the company side, I don't see an issue, honestly. I think the main thing government should do is make it easier for you to keep up the speed of innovation. That would be the greatest thing. Yeah. So as we have only 1.5 minutes left, I would end this session, because I believe heavily in wishful thinking, to be honest. And this is why we're here today. This is a morning talk all about. No, I'm kidding. So Philip, I mean, this is a strong initiative. I'm so glad you're doing that. So if you think 5 years ahead, where do you want AM stand in Europe in 5 years? I know that's a difficult one.
Yeah. No, as I said, what we would like to reach, there is a specific strategy on additive manufacturing, but nevertheless, as Carsten said, we should not be too disappointed if it's not so clear, because it has to be embedded in a more general advanced manufacturing strategy, and it has to be there. So I would be very proud if we can see in a couple of years that we really see that this taken up in all kinds of policies, and to come back on your remark, we want to have key performance indicators because nowadays they are working on the multi-annual financial framework. This is the budget for the Commission for the next period. So it's the competitiveness funds. So we try to make it clear to them that there must be clear objectives on deployment of additive manufacturing, on also, for example, on research and innovation, that the money spent is of course with a high impact. That's also something to, but there is a specific budget.
We need to think about the marketing of what we're doing as well.
Yeah. So that I think.
Yeah. Let's earn money. That's the best marketing. Carsten, your wish.
And as you see here at Formnext, we have a lot of innovations. EOS pushed their new machine into the market, a new machine from many other customers coming in, new innovations. In 5 years, additive will be a native option in any manufacturing workflow in this industry, side by side, milling, additive, playing, wherever which technology is best. And AI will push it. Every engineer will have agents working for him to help on design. We call it speech, 2 parts. So this will as well enable the technology further, and just visit the fair and you will experience this mood across the Formnext.
Carsten, that was, I couldn't have said it better. That was awesome, Carsten. Thank you so much. So you set a good mood. Thanks to both of you for being with us. Excellent discussion. Thank you so much.
Thank you.
So ladies and gentlemen, this was our morning talk, and you should stay tuned because after this very fruitful, inspiring morning talk, we will talk a little bit about the most important thing probably if it comes to success of an industry. We talk about money. So stay tuned because after that we have a fantastic panel according to business cases. See you in a few minutes.
From craftsmanship to code, Fidentis GmbH is transforming dental technology. A Fraunhofer IGCV spin-off, Fidentis has developed the world's first commercial multi-material additive manufacturing process for telescopic prosthetics. This innovation allows the fusion of precious and non-precious metal alloys like cobalt, chromium, molybdenum, and gold within a single build, achieving micrometer precision and eliminating manual adjustments. Where traditional dentures required years of expertise and labor-intensive polishing, Fidentis delivers patient-specific prosthetic frameworks with engineered friction fit built directly into the design. The result is reduced metal waste, greater consistency, and scalable digital production. By bridging CAD/CAM workflows with industrialized multi-material AM, Fidentis establishes the first fully digital chain for removable dentures, redefining precision, access, and quality in dental care. Sometimes innovation begins with the smallest breath. 3D My Mask, developed by Digifab in collaboration with the International Advanced Manufacturing 3D Hub, creates custom silicone masks for premature infants using 3D scanning and additive manufacturing. In neonatal care, one size has never fit all. Standard nasal interfaces often cause air leaks, pressure injuries, and craniofacial strain. 3D My Mask changes that by tailoring every curve to each child's unique anatomy, reducing air leakage by up to 60% and improving comfort and safety for the most fragile patients. Driven by a clinical industrial alliance that includes Hospital Clínic de Barcelona, IAM 3D Hub, and multiple technology partners, 3D My Mask shows how empathy and engineering can breathe new life into medical innovation, because even the tiniest patients deserve the best of technology from their very first breath. At Tesseract Technologies, motion itself is being re-engineered. Traditional large-format 3D printers depend on belt-driven stepper motors. Tesseract replaces belts with proprietary linear motors that glide directly over magnetic rails, eliminating transmission errors, improving speed, and ensuring consistent print quality regardless of printer size. The secret is accessibility. By designing their own motors from the ground up, Tesseract has cut costs by 5 to 10 times compared to industrial alternatives, without compromising performance. Already piloted with leading manufacturers, this technology brings industrial-grade motion control into reach for the entire 3D printing sector. With Tesseract, large format printing is no longer a compromise. It's a new benchmark for precision, reliability, and speed.
Throughout the week we have loads of events. There's special cases, for example, for the construction industry. There's a special case by the VDMA for mechanical engineering. And there's loads of other events taking place, for example, our award ceremony on the Thursday night, where also our visitors can still vote to define the winner of the event. And then, of course, we have our stages with loads of presentations, of talks. There will be panels on very urgent topics, for example. There will, of course, be a review of the last 10 years, but there will also be an outlook for the next 10 years. We are talking about the role of desktop 3D printers in the context of adoption of additive manufacturing in the industry. And we're talking about mergers and acquisitions. So topics that really define and change the industry as we know it.
Good morning again, ladies and gentlemen, and welcome back here at the industry stage in our live stream at Formnext 2025. Before we went into the highlights, I promised money and profit, and this is why we have this panel today. So looking at additive manufacturing, it has come a long way. I remember from being a fascinating technology that sparked innovation across industry, it is now expected to deliver something very concrete, real business value. For a long time, we have talked about potential, about design freedom, flexibility, and innovation. But today, the question is different. How do we make additive manufacturing profitable? What separates the hype from sustainable success, and where are the real business cases that show this technology can truly compete and create value and production? And that's exactly what we're going to explore together in this session called Business Case, the Journey from AM Fascination to Profitability. And of course, you need some experts, because I'm not expert. That's why I invited some expert. So we have there in the middle, Thomas Pang, who is CEO of Additive Japan Corporation and adjunct professor of Nagaoka University of Technology. Thomas, it's a pleasure to have you.
Thank you. Thank you.
Then we have Massimiliano Cecconi, is that correct? Cecconi, thank you so much, Massimiliano, who is Innovation Engineering Senior Executive Director at Becker Hughes. It's a pleasure to have you. Then we have Lars Waumans, who is R&D Manager at Signify. And this is a fantastic story. I'm so much looking forward to that, Lars. Thank you for being our guest. And to my left, and this is why I have to say always the last name as well, we have Thomas Müller, or rather Thomas Müller, sorry Thomas, who is Production Engineer for Digitalization and Innovation at ENBW. Great to have you all here. Thank you, guys. So Thomas, let's start with you. And it's because you have the longest journey, right, from Japan. So you have spent more than 35 years, that's incredible, in additive manufacturing. And I tell you, it's not the beginning. So 35 years is not enough to experience the beginning. So guide us a little bit. Where do you see the current state of AM adoption in Japan? And what needs to happen there in order to get the companies in AM profitable?
Well, thank you for the introduction. And 35 years sounds like a long time, but it was just like yesterday. And I still feel 18. So I hope I look 18.
Yeah, absolutely.
Yeah. So with respect to the AM adoption, just very quick history. I think the first thing I'd say that the prototyping application probably was successful everywhere around the world. Japan was the same. There was a little bit of delay in terms of CAD adoption. 3D CAD was a little later than the rest of the world. But then prototyping and was in R&D, was extremely successful in Japan, and then of course all the other applications start popping up. And if I jump to today, especially after looking at the trade show floor, I really see that a lot of struggle is going through in trying to move into production. And that's because production and prototyping are very different because the requirements are different, right? And I think that in Japan, by the way, if any one of you come to Japan and talk to manufacturing engineers, bring up QCD, quality, cost, and delivery. So quality is the quality, cost is cost, and delivery is time factor. And when you move into production, all these requirements just shoot up like hell. In prototyping in Japan and elsewhere, you can imagine that all you need is time. Iterations faster, you run your R&D, it's a cost center, you don't need to generate profits, right? So it's a lot easier to justify that.
Okay.
So there's a huge barrier between the two, and Japan is going through a lot of challenges, especially with the metal 3D printing, because it costs a lot more, takes a lot more complex technology to learn how to run them. So I think the needs are the same in Japan, but I'd like to kind of just bring up the automotive industry, because the automotive is really special. It goes all the way from $20 million per car in Formula One cars all the way down to, traditional passenger cars. For Formula One, you're looking at $20 million per car. So you can bring on new technology, metal technology, and there are two companies in Japan running Formula One, Toyota and Honda, very famous. They're all using additive without a question, just tons of them, right? So you bring down to all the way to the passenger cars, 30,000 parts for $30,000, $1 per part. So that's a challenge. You can't just bring on 3D printed parts into components and make them production parts. So that's where I think it is. I'm here to try to help the Japanese manufacturing companies to learn about additive and hopefully adopt additive and, make some revenue and make some profit.
Very good, very good, very good. Masuyano, you are coming from, at least, let me tell you that, kind of my dream industry in terms of talking about additive. Tell you why. Because from the very beginning I stepped into additive, we talked a lot about how getting into these use cases of decentralized spare parts for the energy sector, for example. This is where you are into. So you are one of the few companies that already turned additive manufacturing into serial production. When you look at the economics behind it, what made it work, and where do you still see barriers?
Yes, so we actually use, we have several components in our turbo machinery, both gas turbine and compressor, actually manufactured in, I would not say large series, but pretty medium series. And to me, there's been a couple of key points. One is to find the right spot. So the right components that can benefit of the technology. This is not a technology that can solve all the problems. That was a little bit a dream maybe a few years ago. Now we are on a more realistic approach. And you need to identify parts that, first of all, needs to be redesigned for additive. This is key.
Yeah.
Because if you transfer the same design that was thought for the more traditional manufacturing to additive, typically the business case doesn't work. You have to redesign the part in order to make that cost-effective using and leveraging the additive capabilities. And this is what we did for our components. The second key driver is the extreme simplification of the supply chain. When we look to the traditional manufacturing, especially today, it's very complex because parts, in many cases, go through many suppliers. So also the logistic, the management means that we have a lot of hidden costs that probably are not so evident, but are there and add a lot of complexity. With additive, we have been able practically to keep everything under the same roof. So very simple, everything was made there, with also the benefit of, let me say, preserving the intellectual property, okay? Yeah. Because that's important not only for the new units, but especially for the spare part business, for service tomorrow, okay? Just to avoid that someone else copy your part and maybe enter and disrupt your market. So those are, let's say, I would say the main drivers that made successful the introduction of additive and turbo machinery in our case.
Very good, very good. Lars, I promised already when I announce you, because what I really like Signify, that is a real AM business case. It's not like, you know, a plan or something that is already happening. So you have a global operation, you have 1 million printed luminaires sold. So what was the idea? Sorry, I need to start. Who came up with the idea and how is it working? And is it really profitable? That's something that I would be interested in.
Well, the answer to the last question is yes, it's profitable.
Thank you.
I think if you look back, so lighting is a high volume, high diversity, very cost sensitive industry. There's a lot of competition ongoing and you need to find something to basically distinguish you from your competitors. So that's how it started. And Signify, as being a very innovative company, started with 3D actually to do kind of, how do you say it, designed specifically for a customer. If you want something, you can do it with additive manufacturing. That's how it started. I think our journey of the last 5 years, we spent really some time on soul searching. Where is now really the value we can offer to the customer? And it was for sure not in that customization part. Partly it's there, but that's not what it is. So we spent a long time really looking what is now the value we can offer to our customer. And that turned out something completely different, but the moment we knew it, we could organize around it. So we are on sustainability, we are on a certain design freedom, but we're also on what we call speed and reliability. We're just much faster, much leaner in the supply chain towards our customers, which is in lighting a big benefit. The same like what you say. And I think the moment we have identified it, we built everything around it. So if you look to our customer communication, we don't talk about AM or 3D, we talk about the values. We only talk with customers where the values resonate, because the other ones, we anyway have no proposition, so let's spare ourselves the time. And if you look at the technology side, these values we offer from our technology platform, everything else we sacrifice to make it economically attractive. And I think that whole package brought us the last years where we are now, which is then basically indeed the 1 million products we sell every year globally and being profitable, which is a nice one.
Just one sentence in order to get the audience on speed. Give us an example for one specific product and one specific example customer.
Yeah, so we have a customer, we have a company called McDonald's, which I guess everybody knows here.
Nobody.
So globally, yeah, that's a very global company, but McDonald's has a concept where you buy a restaurant decor, as they call it. So it's about, and that is the chairs, the lighting, whatever is all in there. So we came in contact with McDonald's, then you see the opportunity and the speed you can do there. Within 2 weeks, we actually, so they had a design, they sent it to us, we print it, send it back, and change a little bit. Within 2 weeks, actually, it was fixed, and then we could roll it out over, I think 160 countries in the world where we're now selling it. That was decor number 1, but that became such a success due to the cooperation we could do with them, that we're now actually in 12 of their decors. So that's how we expand.
Awesome. That's a good story. Thomas, coming to you. So we are, especially me, I'm kind of dependent on you because you are producing energy. So if we're talking about EMBW, you are an energy provider, basically. We're talking about safety, reliability, and uptime at any time. Yeah. So the question is, how do you use nowadays additive manufacturing? And as we are looking on profit, do you see already an impact on profitability and keeping the uptime already in your organization?
Thanks for the question. First, a short disclaimer. I'm focusing on offshore wind today because that's the field I'm working in. Yes, if it comes to economics, for us it's very important to analyze each part if it's possible for us to have a cost-efficient way to produce it with additive manufacturing. I'm focusing on spare parts. So we have to analyze each part by its own and find a way. Especially if it comes to downtimes of turbines, this always means a revenue loss for us. So if it comes to downtimes or possible downtimes of turbines, it's very promising that there is a economical case for us. But also, what's also important for us are the surrounding organizational challenges. So we have to check for each part if it's possible for us, or under which circumstances it's possible for us. Are we allowed to print parts by our own and bring them in the turbine by our own, or are we have to rely on the suppliers?
That's a good question, because I know whether you've seen it. So we have been heavily discussing with Deutsche Bahn, and we saw their progress over the last 10 years. And that was exactly the issue they had, because you are in a safety and reliability environment. So what would you say? Is it rather handing over the responsibility to the supplier, or is a strategy, I mean, you don't know yet, but in which direction is going? Having it internally, or rather rely on the supplier? What do you see?
I think the best way is to have it internally. So to a certain degree, you can bring it to the supplier. But when it comes to the legal frameworks like warranty obligations or insurance, or our contracts we have with the supplier, so this is all we have by our own company and in our own hands. So I think the main we have to bring the main solution in this topic.
Okay, very good. Massimiliano, I mean, that's why I said dreams come true, yeah? I mean, we of course, remember all the advantages we mentioned 5-10 years ago about additive manufacturing. We promised decentralized warehouses, like digital warehouses, and especially in your sector, I mean, you are not at the spots where usually you go by car or anything. So do you see a few of these advantages already came true in your case?
Yes, and I can mention a specific example, because our service business is serving a very obsolete fleet. Some of our oldest gas turbines were installed in the 50s, in the 60s, and approaching spare parts, especially the hot gas components that are the most sophisticated ones, typically made using investment casting. It's not economically viable, because many times you have to produce a few components for specific customers on parts that probably do not have any more a large market, a large applicability. No? So in that spot, the additive fits very well, because practically we can restart the production of components that typically were, let me say, cannibalized by non-OEM suppliers. So we went back in that market, offering spare parts for those very old gas turbines. Maybe in the meantime, also introducing some design enhancement, so some design performance enhancement to the turbine itself. So that was seen by the customer as a big added value. And this was leading to a production that is still, let's say, centralized. So the future thought is to localize the production closer to the customer, maybe at our service shop, in order to serve them more quickly and more efficiently, okay? So this is a business model that I'm realistic, is having some up and down, is not fully developed, but it's starting to have some success, okay? And starting to create its own space in a market that shows to be profitable, more than new units by a certain point of view.
Let me add one short question that leads me over to Thomas again. What about trust? I mean, you are talking about, as you said, there's a turbine from the 50s or 50 years old?
From the 50s.
From the 50s, so that's 75 years basically, yeah? So we are talking about things that work for decades.
Yes.
So you're coming now and telling them, hey guys, we don't need a big warehouse anymore. Don't take, I don't know, 2 years to replace parts because it's individually produced. We can fix it. I won't say by hours, don't get me wrong, but we can fix it with additive easily. So, but they are relying on 75 years running smoothly. How do you convince them with additive?
That's a key factor, I would say, is the key winning factor, if you want. It's part of the acceptance, in general, of the acceptance of the technology, especially in regulated markets, okay? So oil and gas, nuclear, aerospace, they are very regulated, so clearly you have to convince not only customer, but in many cases also the entity, the regulation standards. How do we do? This has to do with all with putting in place a very rigorous validation process, starting from the material, from the metal, from the alloy, and then growing up to the component, showing that at least a component level, and sometimes also testing into the engine that the part is durable enough. Clearly, we have to create a long-term experience that today is still missing, because if you buy an investment casting component, you know what is the expected life from the component that was, as you said, in the field for so many years. With additive, we still have to, overall as a community, to build this kind of credibility and trust, but it's on the way. It's on the way. We have components and now have experienced more than 2,000, 25,000 firing hours, as we call them. So practically components stay in the front of the flame coming out from the combustion chamber, and they behaved very well. So this trust, this credibility is growing. It's growing up.
Very good. Sorry, I need to skip Thomas for 1 second and go over to Lars again. So Lars, one question to you. Same topic here.
Yeah.
So if you talk to a client like McDonald's, and we are not talking about there's one shop where you test it, that might be the beginning. So you have to use it, and I know they're selling the concept to franchise partners. So how did you convince them? Were they convinced right away? But there again, it's about durability, quality, functionality. What was the story behind that?
Yeah, but it's the same answer actually. We also have actually a very stringent quality process, which we do more on our platform level. So we know what we are capable of. We also know where it cannot work. And that is where we convince them. I think together with a few use cases. So when we started, actually, we turned the full lighting in our own office to our own lighting. So we're always ahead of the market, actually, if something happens. So that's one thing. I think the other thing, what we also see is, if you look at our cost of non-quality, so what we get back out the fields, it's very limited on the printed quality. There is a lot of I mean, we have electronics which might fail. Has nothing to do with 3D printing, but with also that data we're gathering, at least to show and build the trust towards our customers that it is a reliable product, just as reliable as a traditional manufacturing method.
In comparison to traditional, does the client has to pay more because it's better, or is it basically in the same price region? Let's put it that way.
So also in the lighting world, you have high end and you have low end, and we're somewhere in the value for money range. So in our case, if you want the lowest of the lowest lighting luminaire, don't come to us. Then let's be sure. Then just import something from China that will fulfill that value. But if it's really about the value we offer, then we are very nice priced.
Yeah, very good.
So we are pretty close to. We are actually at market average there. That's.
So Thomas, let's tackle a little bit the topic of efficiency. And sorry, that's basically because you're from Japan. I'm a big fan of lean management. This is the mother country of lean management. We're talking about efficiency. Is that a driver? I mean, you are not only focusing on Japan. I mean, you're in your work, but you have a very global overview. If you consider additive manufacturing to getting profitable, is efficiency a driver?
I think efficiency is a big part because it affects time.
Yeah.
But I think, again, I'll go back to automotive because it's kind of the largest representing Japan. When it comes to automotive, quality is so important. And the challenge in terms of the cost per part is always, if you only need 100 parts for spare parts, you still need additional development effort to shift into additive. Is it really worthwhile? That's the biggest challenge. And I know I may have given everybody a little bit of negativity in terms of automotive adopting additive, but even in Japan, where it's very conservative and quality requirements so high, they don't want to change into new technology. There is a movement. It's the need. Because if you want to make a spare part and tooling is not there, are you going to create tooling one more time? There's no way. You're already losing money to start with, right? That's where additive comes in. There's a need, and not so much efficiency, but here's a way that's the only way to make money, right? Not to make tooling, but convert to something. So there's a couple of examples there, but I'll talk about it later. But the efficiency is only one of a few items, and because when it comes to production, it really is, in Japan especially, stable delivery is more important than doing quickly. The time factor is much larger in the research and development for iteration, but in production, it's stability, consistency. You know, you start from Six Sigma, and then you work further so that you don't get any, problems with your products. So you always have to focus on quality, and cost is important to generate the business proposal, but delivery somewhat. Time factor becomes slightly less, I think.
Okay. So, Thomas, we heard Massimiliano talking about the 75-year gas turbine or whatever. Yeah, so turbine that is fixed with So you are meeting some restrictions and challenges, right? I mean, let's talk about that, because getting profitable is not like there's a business case behind. Sometimes there are 2 or 3, 5 challenges you have to overcome before getting to this business case, right?
Yes. There are like organizational challenges, not like the technical ones. The technical, we can rely on in the industry and on the possible service suppliers you see all around here on this fair. And we do also have a huge trust in them. But the organizational challenges are very big for us, and which is actually the bigger factor for us to bring additive manufacturing in the service of the turbines. One part, as I said before, is insurance and warranty obligations. So the question is this still valid or not? Same thing is for the certification of a turbine. Does it still stay valid if we use our own produced additive manufacturing parts? Addition to that is intellectual property and patent rights, for example. So regarding to our internal legal experts, we need to do for each part an extended research about the part, a spare part itself, and for the assembly, if there are any IP rights which we possibly harm. And yeah, that's always a big effort for us, and not only time but also money to do these researches. Yes, and what also comes to mind is the acceptance by the colleagues. So the technicians and the engineers, they need to gain trust into the technology, that it is a possible solution for us. So all these adding up are big organizational challenges. And the way we find it for us is the possible best way to solve these challenges or hurdles. Is going step by step. The first approach was to bring high-stressed, high-risk parts in the turbine using additive manufacturing, but then we had to answer all these questions at one and the same time. And now the approach is a bit different, to go step by step, smaller parts, less risk parts, and learn on the journey, and to answer these questions step by step.
But on the other side, and this is probably something, Massimiliano, and you can answer together or estimate together. I'm a strong believer. If you want to drive something in an organization, the best way is to show a possible profitable outcome, or let's say an impact on the balance sheet afterwards. So how important is it to prevent downtimes, for example? Okay, how costly are downtimes compared to a quick fixture that probably speed up the process of regulation? I mean, we all know if there's pressure on it, it goes much faster. So how do you experience that at EnBW? Is there a cost perspective, or started it all with a technical perspective?
For us, the main factor how it started is the chance to supply the parts by the original manufacturer in an acceptable lead time. So time is always a factor for us, and especially when there is a possible downtime of the turbine, we want to avoid this at any chance. So downtime is for us the main factor. So we wanted to have a quick solution to keep the turbines running.
Massimiliano, what was it?
That gets back a little bit to the example I was doing before about parts for service that clearly accelerate, create a warehouse of spare parts that can help customers to limit the downtime in case they have a failure or they have their planned maintenance on the unit. For sure, that is something that the customers really understand, and also help to accept this new technology that, as I said before, has for sure barriers that comes from the international regulations. We have to work with them in order to qualify materials according to the standards, but also cultural. There is a big cultural barrier, not only from customers, I would say also internally, from engineering, because we are all used, we all have been educated to manufacture components, parts in a certain way, and this cultural shift is a big effort. So when we started this journey into our company, that was around 2011-12, believe me, the cultural resistance was very high. So we had really to prove that we were able to make complex parts, complex geometry, and that the material, the mechanical performances were really sound for the purpose they were used for. So it's a journey that is not finished, it still continues. So this is, if you want, an internal barrier on top of the external ones that are there. In terms of business case, there are parts where it works and parts where it doesn't work. But there are, to me, other aspects that must be considered that could be interesting. That are, for example, the environmental impact. Environmental impact. My group has done a couple of interesting papers on this topic, comparing the same vein, turbine vein, manufactured using investment casting and manufactured using additive. And it's proven by all the analysis that we have done that the one made in additive manufacturing has 25% less CO2 impact than the other one.
At the current state, right?
At the current state.
Yeah.
So not even considering what to me probably is one of the most important barriers today, that is the scalability of the process. That is a big topic we should talk to.
Very good, very good. Lars, you needed to do business, right? Nobody said to you, it's a nice idea. R&D, Lars came up with an idea. So I think the first or second question was, can we make money out of it, wasn't it?
Yes.
Or was everybody fascinated, just try it out?
No, that's true. So actually, there wasn't the one who came up with the idea. So that's let's also be honest there. But it is. I think, yes, there has always been a business case, and that I think what helped us there is that we were allowed. So we are part of Signify, which is a very big group. We were acting as a kind of a startup scale-up. So the first few years, nobody really worried about us making profit, etc. We just need to invest and keep on showing that we were reaching that target of becoming profitable. And that's kind of structure built around us. That helped us a lot to go just all in. And that brought us where we were. But again, it was a journey, because our original idea, we never materialized. The only thing in that journey, we found the true value, and that is something we managed to industrialize then.
How were the concerns there? There was probably not an engineer barrier, which I usually see if it's at a very technical level, then usually it doesn't have to do with, it's not an end customer, it's still B2B, but usually the engineers are more open in your environment, I would assume. What was the main barrier inside the company?
No, so the struggle we as a company have, as Signify in general, is always we have great technology, how do you market it?
Yeah.
And I think the big change for us started when our general manager, which was always from the AM part, we actually was at one moment being succeeded by somebody who was, again, a lighting general manager. So he started to think much more as lighting, and we really turned from a 3D business towards a lighting business again. And then you start driving the right discussions with your customer about what is the value. Again, I'm repeating, but what is the value? What does it mean for you? And also from that feedback, steer actually the technology development to what's relevant.
Yeah.
Because otherwise you go all the way and it's all very nice techno push, but it doesn't deliver money. That's.
So yesterday, I tell you what, I had pretty much the same discussion, and I talked to somebody investing in startups, okay? And we were discussing is it first the problem or is it first the idea? What comes first? And usually if you have a need, then it's much easier, of course, to solve the problem or to deliver something that ease the need.
Yeah.
So in your specific case, so there's a need of lighting. Honestly, in the first steps, I wouldn't think about additive manufacturing solve any problem. How was that?
No, but there was a need, we thought, of customization. And indeed, to a certain extent, there is a need of customization, but you can drive that to the extreme, and then actually your customers got tired of customizing, because at one moment you can customize so much, nobody takes the time to do that anymore. And at that moment, there will no AI tools to do it. So you can also, yes, you can identify it, but then really bringing it to the level which makes sense. And that's, I think, what we did in the end. That is still something where you need to understand the market and what your customer wants. And an R&D department or a technology department can typically not do it. You need other, more commercial functions helping you there.
Yeah.
And I think that was a switch we had to make.
Okay. Very good, very good. Thomas, considering Japan again, or rather representing a certain type of economy that you perfectly described, so what are the missing pieces to focus more on the profitability of this technology rather than use it for specific use cases, like prototypes, for example?
Yeah, I think right now trying to adopt additive manufacturing to make money is still very difficult, because making a part and selling, that's the simplest concept. But anybody can do that. If everybody can do that, then you have no competitive edge. Yeah. So that's kind of out the door, right? And then you need to start working on where do you add your value? What is the spot that you will gain the most from what you do? One example is, for example, not so much money. Let's say, how do you make processes efficient? One area that's growing in utilization is jigs and fixtures and the tools used in production floors. I mean, it's not the product that you're sold, so your risk is very low, right?
Yeah.
And the Japanese people like lower risk, because risk is such a huge barrier there.
Yeah.
So if you start doing that, all of a sudden everybody is making more money. It's very clear, because just buying jigs and fixture itself could be $1 million a year, depending on the factory, right? All of a sudden you're spending a tenth of that, and then you're doing things 3 times faster. Your quality is getting better. Your Kaizen days are more effective, and so forth. That's clearly a money maker for a large factory.
Okay.
So jigs and fixtures, one. But the other areas I think we need to look at is how do you really lower the mindset, the risk mindset, because risk plays a huge part. I mentioned QCD. Everybody talks about QCD. Engineers already worry about QCD, your supply chain is telling you to cut costs and increasing quality and so forth. But the risk part is where the decision is made by the managers. I mean, how many of the startup people actually run through 100% simulation that it's going to come out exactly the same? The part that makes the decision-making to adopt AM the most difficult, based on experience, is just risk. So how do you, lower the risk? That's kind of the task on my hand. I want to find ways to lower risk. And then the best way to lower risk is spread them, like creating collaborative environment. If with 10 companies, the risk, monetary risk is 1/10 of them. You get more brains in them, and you have more discussion, decrease mistakes and so forth. So I think risk is such a big factor. Everybody focuses on QCD so much because that's your business, but the managers, the top management's always making decisions based on what there is. Best scenario, worst scenario.
Which is kind of hindering a little bit the innovation part of it, right? I mean, this is kind of not driving it. Lars, what is next to come? That would be interesting for me, because this sounds like a very successful, I don't want to call it project, because it's like a product rather, right? A product group, let's say. Are you extending the business in this direction?
Yeah, so internally, or at least we're in lighting, we're only in indoor lighting. You can go outdoor, we can do much more. So we're actually only in a small part of lighting, so we're now expanding in that lighting area. What I actually hope the next step is more competition. So we see limited competition. That's not, that to a certain extent it is helping, but also to a certain extent, competition just makes you sharper and drives it further. So that would be a very nice next step. And I hope actually in a few years that what we did in a more consumerish, good type of industry, that can also be copied to other industries. I know there are a few other great examples, but I think that can be much more.
Okay, very good to hear. Massimiliano, one question to you. So, this is how I started your personal presentation. So my dream was always of having these decentralized digital warehouse, especially in your field of industry, because I mean, this is in most of the world, those are the backbones we need in order to have still industry running, up and running, you know, and infrastructure up and running. How far are we away from these decentralized digital warehouse where I say they can use, I need a spare part, guys, call Massimiliano and said, you're in the Ukraine or you're in, I don't know, in South Africa. Hey, no problem, I call the local supplier and you will have it in, let's say, 2 days.
No, we are not there, to be honest. We are not yet there, but clearly we can leverage a good network of service shops that we have in key critical areas that we want to grow and go in this direction. So clearly we have a technology transfer to put in place. It's as I said before, it's a journey because we have to go through the education of the customers first. So we need to have the acceptance of the technology from them, be sure that there is a good business case for both. As I said before, I mean, this is, at the end of the story, is a cost-effective technology. The problem that we see today is scalability.
Yeah.
Is scalability because, I mean, we have to grow the production. That requires a lot of capital investments. How we can keep that capital investment pretty low, because otherwise it's not sustainable, no? And when I look at that, is capital investment for new units, for new components, but also for service, because if you start to think about having a network of service shops that can provide almost real-time components is a big investment that we have to go through. So the next chapter we expect from this industry is to have equipment that can support this scalability. It's not only a question of size, it's a question of productivity and efficiency from the equipment. Otherwise,
on the other side, if I think about cost for warehousing and storage, would be the counterpart, right? I mean,
yes,
we're talking about heavy investment. I totally believe that.
Yes,
especially if you want to keep the IP and make it yourself, so you keep probably the machine.
But in that case, that is a little bit less worrying because you find agreement with customers, so you don't have to keep all the cost of the inventory on your shoulders. But it's something that you can eventually share with your customer under specific long-term contract agreements. So you find a commercial way to manage that. The problem is really the scalability of the process in order and to have a reasonable investment.
Thomas, brings me back to you because we are talking about offshore energy supply. So it's not like you are driving to Stuttgart and saying, hey, you have a problem here, I solve it for you. So how's it, what is then, I mean, I understand totally that it's probably a faster lead time to a spare part, but still it has to deliver it, right? I mean, and we are not talking about small parts, right? I assume at least. So how is that working? Well, how's that considered? Or has additive an impact on this topic?
Yes. First of all, we are focusing on the later lifetime of the turbines. So we are operating the turbines 25 plus years. And when it comes to the later lifetime of the turbines, we see that we see a higher failure rate by parts. But we also see that the original suppliers sometimes can't supply us with the certain spare parts we need, because they are focusing more and more on the newer turbines, which are more innovative and bigger, of course, and not so much on the older ones. But we also have them in our fleet. So it's interesting for us to find a solution, how we can operate them effectively and safe as well. And what's also interesting in the offshore scenario, it's a unique location. So we, for example, work in 14 days shifts and only have in this rhythm the opportunity to pick up our equipment, and not always under this rhythm the chance to bring out parts by vessel or by helicopter. So we are a bit limited in that way regarding to logistics. So the time factor for us, is always a big thing, and makes the planning challenging.
So it could be that at day one of the 40-day shift, there is a defect and you have to wait 39 days up to the next delivery, right?
14.
14.
Yes.
Okay, yeah.
Yes, possibly we have to wait.
Even 14.
Yeah.
Yeah.
2 weeks. Yes.
Okay, good to know. So let's use the last 5 minutes. I must admit, and I'm sorry for that for you, I studied economics. So if I think about new technology, about application, about adoption, I always think in the business part of it. That's nothing I can take out of me because this is a business decision. Massimiliano, you described it. At the end, there must be business. So I experience additive very much technical driven, most of the time, driven by engineers, kind of solutions. And I love the idea of putting more the money view on it because we're in a consolidation phase and only the fittest will survive. Don't stress that topic too much, yeah? But in the end, you are vertical, you are vertical, you are vertical. So we need to find a way to make the use of the technology at the same time profitable. So what would be the most important step, starting with you, Thomas, in order to get into the whole thinking, the money part of it?
Yes. As I said before, for us, time is the biggest factor. If we have downtime of the turbines, the operational phase is the return of investment phase for us. So if we have any downtime during that phase, it's always a revenue loss for us. So if we can reduce the downtime of turbines or possible downtime of turbines, it's really beneficial for us. And yeah, we did the analysis of the economical potential and it's really promising. So I think when we can tick all the boxes of the organizational hurdles I mentioned before, additive manufacturing would be a standard solution in the future, especially when the fleets are getting older and older.
Okay. Downtime reminds me of automotive, Thomas, because downtime of a production line, this is what we at BMW calculated all the time. And this was a big red card you keep upholding once we're talking about money. Thomas, what do you think? We have here downtime or being faster in replacing. That's one of the key drivers to...
Yeah, interesting enough, the way Japanese companies take care of downtime is hold plenty of supplies.
Yeah.
And it's very different than the rest of the world because mistakes are totally forbidden. You do not make mistakes. This is a country that trains are managed 15 seconds at a time.
Yeah.
So it's a very different mindset, and that brings up the quality of Japan. But in terms of I think your question on additive, try to make profit and so forth and be useful. I think the most important thing is education. And then to create an ecosystem where people know that there is a supply chain set up to deliver what you need. Not just 3D printed part. You need the certification, you need standards, you need supply chain with people who have knowledge. And then you have all the educational system to decrease the risk that, hey, I can do this. And there's going to be 25 suppliers available to provide ABC, doubling up everywhere. It's sort of like a pyramid style, especially in automotive and, kind of distributed, manufacturing compared to the, vertical manufacturers. So you really need to make sure that creating an ecosystem with a balance and stability, that's one thing additive has been missing. Great, beautiful stories, great success. If you make it, it's going to make it 100 times and, do everything in 1/10 the time, great. But that's one time. There is no guarantee. You have that next time it's going to be succeed, right?
Yeah.
So in automotive, you got to do this, with Six Sigma mindset.
Yeah.
So you got to do it a million times, and you cannot fail a single time. So you need that for people to jump in and invest in additive.
So we have risk reduction and stability of the supply chain as a driver. Massimiliano, what would you say?
One of our most successful component in additive is the fuel burner, is the element that inject the fuel into a gas turbine, okay? And we have designed it for additive, and this is a choice that probably today is not reversible anymore. It's very difficult to get back to a traditional manufacturing technology. That means that the technology must help us to follow the growth of the demand.
Awesome.
Because in this moment, for example, it's well known the gas turbines are experiencing a bubble of production to support the energy demand from the data centers, especially in the United States, but probably in the next future worldwide. So how we follow this growth of capacity with additive, that is, let me say, a technology is born as a prototyping, so it's not made for large numbers. So now the dilemma is how we switch and we move from something that was thought for prototyping to something that is really massive production as needed from this growth.
But I see a demand driver here, right?
Yeah.
Basically, that's, very good. Lars, you get the final one. What drives in your business additive to more profitability?
So for us, the values were already mentioned. It was really about sustainability. It's about design freedom in the professional context. And it's about speed and low opportunity cost. And I think, but that's for us. And the only thing I can say about another company, really find your value, the value you want to offer, and build it around it. So that's how you can become profitable. So that's
the best tip, at least, at the very last point. Thank you very much for sharing your stories, your success stories with us. Good luck with your future projects. Keep going on, pushing additive in your business. That would be a pleasure. So, ladies and gentlemen, I hope you enjoyed this panel. I enjoyed it a lot. We will have an exciting keynote afterwards, so you stay tuned. But before that, you can enjoy a few minutes of Formnext highlight. Enjoy and see you in a few minutes.
Alonic is revolutionizing robotics manufacturing with 3D tissue braiding, a world-first technology that grows complex, movable robot bodies directly from functional fabrics. Using a seamless software-hardware platform, the company enables automated creation of flexible robotic structures, arms, fingers, and joints without assembly. By embedding elastic fibers, sensors, and wiring within a single 3D textile form, Alonic reduces costs, speeds up prototyping, and redefines how machines come to life. This is soft robotics, engineered with precision, where design meets biology, and the next generation of human-safe automation begins. BioMotion is transforming life sciences with industrial-grade 3D bioprinting, making it as reliable and accessible as modern manufacturing. Their high-precision platform integrates automated parameter control and intelligent supervision to ensure reproducible results. Every single print, every single time. This innovation empowers pharmaceutical and biotech companies to replace traditional 2D cell cultures with 3D human tissue models, accelerating drug discovery while eliminating the need for animal testing. By bridging biology and industry, BioMotion is enabling scalable, ethical, and data-driven medical research for the next generation of therapies. Nurio is unlocking new speed and creativity in engineering design. Their AI-driven 3D software tools automate repetitive CAD tasks and generate production-ready designs for additive manufacturing within minutes. By capturing expert logic into code, Nurio's plugins and online configurators drastically reduce design cycles, improve manufacturability, and cut costs. From aerospace to tooling, they are helping engineers move from manual modeling to intelligent automation, transforming the design process from constraint to catalyst. Osseo Labs combines AI, 3D printing, and bioresorbable materials to create personalized implants that heal naturally within the body. Their Osseo Vision and Osseo Matrix platforms enable patient-specific orthopedic and facial implants, already validated in more than 250 clinical cases. By using 3D printed magnesium scaffolds that safely dissolve as bone regenerates, Osseo Labs reduces surgical time, improves recovery, and minimizes the need for follow-up operations. It's precision medicine engineered through additive manufacturing, designed for healing and powered by AI. Perfy Technologies is pioneering volumetric additive manufacturing, a game-changing process that prints complete 3D parts in seconds, not hours. By projecting light patterns into a rotating vat of resin, their system forms entire objects in one go, eliminating layers, supports, and waste. The compact desktop unit enables on-demand, point-of-care production for customized medical and dental devices with a closed-loop resin recovery system for sustainability. Fast, precise, and solvent-free, Perfy is redefining what's possible in high-speed, sustainable 3D printing.
Do it like that. Do it like.
Come on!
Hello, ladies and gentlemen, and welcome back here on the industry stage. Day number 3, Formnext 2025. We have an exciting keynote to come, and I'm happy you joined us here again and also here again in the audience. Good to have you. So sometimes in manufacturing, we talk so much about machines, data, and processes that we forget the simple truth. Nothing new happens unless someone dares to rethink the obvious. And today we look at a company doing exactly that, taking the idea of one process or the other and turning it into a seamless, amplified workflow. So let's dive in and see how hybrid manufacturing technologies pushes this idea forward and how Lisa Block, who is Chief Revenue Officer, shows us what true ISO amplification can look like in real production. Lisa, I'm so much looking forward to your speech. Stage is yours. Warm applause, ladies and gentlemen.
Hello, hello. How are you today? Thank you guys for being here. I'm so excited to be with you. I'm going to be talking about manufacturing with intention, and I know that we are sitting in this environment overwhelmingly excited about advancing technology. Technology defines the very focus of why we are here. And so I'm super excited to be sharing some new ideas with you. And I want you guys to kind of unplug and kind of reimagine how you can engage in this environment. I'm going to throw some ideas at you that are going to be kind of different to something you've seen in this environment. But I'm hoping that at the end, you'll have some questions for me. I'll be happy to answer them so that you understand where we are going. Manufacturing requires intention. It requires a goal in mind, achieved deliberately and with unwavering focus. I am excited to be in this environment, in one of the most technologically advanced environments in the world, so we can have this very real conversation. Now, I have to be perfectly honest with you. A lot of us that have German counterparts, we also have counterparts that are in the U.S. If you know anything about the U.S., we are exactly 1 week out from the most important holiday that is ever celebrated and only celebrated in the U.S. Anyone know what that is? Thanksgiving. Thanksgiving is important because to Americans, food is important. Food defines everything that we do. And so one of the things that I love doing is sitting and slaving and preparing something very special for the people that will grace my home. My house smells amazing. And the question I get all the time is, what is it that defines your food? Why is it so good? Well, my food is so good because of one thing. I make sure that every ingredient is the best there is. I put care, I put time, I put passion into preparing it so that everyone that interacts in my home, they feel special. Manufacturing is the same way. Manufacturing is the best recipe there is because it requires something in order for us to get to where we want to go. If you'll allow me for a few moments, I want to talk about that recipe. I want to talk about the ingredients that are all combined to manufacture with intention. Very first ingredient, the technology. We are surrounded by a diverse offering of technology, all of these different services, all of these different technologies postured to serve. Anything that you can imagine, someone has said with intention, I know that I can solve that problem. I know that I can show you a new or a more advanced way to do that. And if I'm honest with you, I don't want you to run me out of here for making this statement, but that is the focus. And sometimes I think it's a little overemphasized. Why? Because while the technology is here, because someone dared to push the envelope, the technology would be nothing without the people behind it. The second ingredient is the leadership. Some of our leaders in this room are up every night making hard decisions long after we've all gone to bed. They're making sure that their shareholders are happy. They're making sure that their employees are happy. They're making sure that their clients are happy. They're watching over every KPI. They're doing everything that they possibly could do. The things that you are frustrated about, they are happy to do it every single day. A lot of us talk about our cool technologies, and we don't talk about all the boring minutia that it takes to make it cool. But your leadership is excited about the minutia so that you can go into the applications environment fully creative and fully ready to make new and exciting products. Next ingredient are the employees. Wow. Number one, none of us could do anything if we didn't have people that signed up to come to work every single day. I want you to know that it's not lost on me that all of your gifts and all of your talents, that you bring them into a work environment every single day. You put yourself in a position to be misunderstood. You put yourself in a position for someone not to have any kind of compassion on what you're going through personally. But I want you to know that that sacrifice that you make, it makes all the difference. Everything that you do every single day, it makes all the difference. You are the first line of defense. You are the first person that our customers will interact with. We cannot sell anything without you. We can't sell anything without your expertise. We can't sell anything without your happiness. Everything that you are defines all of these companies in this hall. We are here because you sacrifice every single day. You leave your families, you walk into a room, and you say, how can we be excellent today? I want you to know that there is no bigger component in this manufacturing pie than all of you, than the decisions that you make. And I ask you every single day, I ask my staff, I say, what is the hardest thing about showing up? Every single time they say, we don't always know how our ideas will be received. I want you to know as leaders, because that's what you are, when you make a decision to come in and share your bold idea, I want you to leave room to be misunderstood. I want you to leave room for someone not to think that what you're going to suggest works. Why? Because it is with that intention, when you walk in the room and say, hopefully this is what works, someone says, you know what? Let's try. Let's try pushes us over to a place of innovation that no other decision can. Someone deciding to do what someone said could not be done is why we all stand here today. And so I want to invite you to keep being the ingredient. I want to invite you to keep being the essential part of the recipe, knowing that there is someone who will get behind your ideas and champion them so that innovation can continue to take place. And finally, intention. Lewis Howes said that the world is waiting for your gift. You all have to decide to show up with your intention. Have you gotten complacent? Are you somewhere where you're no longer being challenged? Is your creativity being quashed by bottom lines and shareholders and to-do list items? I want you all to know that remaining in that place where you're intentionally creative, that place where you're willing to try something that you've never tried before, all of that fosters this amazing environment we're in right now. All of us can remember walking these halls and seeing one or two of the same technologies represented. And look at where we are today. Look at the beauty that manufacturing has yielded all of us because we were willing to push the envelope. I want to thank you all for your contribution to manufacturing, to your contributions to the ideas, to the evolution of your minds, to every project that you will put your hands to that your companies can do nothing but benefit from. I hope that you will leave this talk and ask yourself, how hard must it be for me to keep pushing myself forward? What skills do I need to add to show up for my leadership in a greater way? For the leaders, what kind of leader can I be to let my people know that they have the latitude to try something no one's tried before? The more we ask ourselves these questions, the more that our intention will come through. And as that intention comes through, our products will evolve, our industry will continue to push forward, and it will serve as a catalyst to push us into bounds we've never met before. We set the standard for our clients. Everything our clients need, we're the ones that say, I'll address that. Whatever it is that you have a deficiency in, I'll figure out the solution for you. They trust us. And because they trust us, I want us to use that recipe to make sure we're selling the correct thing to the correct person for the correct purpose. Because the world is waiting for your gift, for the thing that you do, for the solution only you possess. And the only person that can determine that limitation is you. My invitation to you today is to continue to manufacture, but don't do it arbitrarily, and don't do it just so that you have a 9-to-5. I want you to do it with intention. Thank you guys so much for listening. You guys have any questions?
Big applause, Lisa. Thank you so much. I shouldn't have come from this side. Sorry for that. Let me stay here. So, first of all, let's ask the audience. I have a few questions, and I have a comment. But probably I bring the comment first, and then I hand over to the question. I love the metaphor about recipe, okay?
Yes.
And as I'm in the field of leadership, as they know, I mean, if you put too much of one ingredient into the recipe, it doesn't taste anymore.
No.
Yeah, that's the big thing.
That's great.
So, and what I experience in additive sometimes, and that's why I loved your speech so much, was sometimes it's a little bit too much technology. Very often is it too much of technology.
Yes.
Very often there's kind of lack of leadership.
Yes.
And what I don't miss is the motivation of the employees, at least. I see that everywhere, but sometimes they're frustrating with the speed. So this is just a statement to make. So I love the combination. Everything have to be in place in the right amount. Otherwise it won't
absolutely.
work, right?
And that, I mean, that's essential. The truth of the matter is any one ingredient that's off, it can completely change the outcome.
Yeah.
And it's up to us to shape the outcome.
Yeah.
So we have to know that.
And to close to the title of your speech, to the intention. So basically, the intention tells us, how should it taste afterwards, right?
Yes.
And sometimes, in my opinion, the components do not know how it should taste in the end. And this is probably where we stand today.
Yes,
so
absolutely.
Best timing for the speech. So sorry for adding something.
No, you're good.
I'm fine. So, dear audience, this is the time where you can ask questions here. Do we have any questions? Where's Antje? There's Antje. There's a question. Sorry, Antje. That's a long way to run.
Thank you. I definitely feel inspired as an individual to act with intention after hearing what you said. I
Yeah.
really like the analogy of the holiday, but holidays bring people together. I definitely feel as an individual inspired. But with holidays, we're together with multiple people, and there's a lot of collaboration that needs to happen.
Yeah.
How do you take account for the people who have to interact with other people in making manufacturing happen with intention?
Yeah, I think that's the good part about the holiday, right? Is that it's not something that we can do by ourselves. We have to be intentional about inviting I think the best analogy for me is the person that is close to retirement and the new millennial that's coming into the company. You've got an old set of way of, of doing things, and you've got a new idea of how to do them. How do we get to the destination? We get there together. We get there by sharing the ideas. We get there by sharing the approaches, knowing that one is not better than the other, but together collaboratively, they make the whole thing work. So I think the answer is together, right? Absolutely.
I maybe add something at
Yes.
this point, and that would be a question for you, probably in the same direction.
Yeah.
So I remember I don't think it's a German saying, I tried to translate it. So
Yeah.
if you want to go with a boat to the sea, don't teach the people how to build a boat, create a desire for the sea. And this
Yeah.
brings me back to intention.
I'm gonna
How
write that
do we
down.
get to the point that leaders are nowadays able to translate and to stimulate the people thinking in the intention of what they should do?
I think one of the things that is the biggest challenge is in environments where you have lots of startups, you don't always have alignment to the vision at every level of the company. And so I think it starts with the leadership making sure that I believe with everything in me that you have to have entrepreneurs at every level of the business.
Absolutely, yeah.
Right? Because they will push forward the vision. So I think driving home that focus, making sure that everyone has the desire for the sea, and that we're constantly being collaborative, and we're not going into the reclusive places that we can go in to make decisions that are hard, but we're staying collaborative with our teams. I think that's the way that we create that desire for vision and that desire to kind of push all the initiatives forward.
Talking about vision, before any more questions, there's a, sorry.
Yeah.
Every question from the audience better than my remarks. Antje, there's another question. Here.
In the front.
Hello. Hi, I'm Sumita from HP, and I'm a finance professional. So for me, all of this was a walk into the world of technology. When a finance individual looks at technology, they always have a cost angle associated to it. So my question is, how do you really kind of concentrate on intention without impacting the speed and increasing cost?
Oh, that's good.
Yeah.
Well, let's be clear. It has to make sense financially and otherwise, right? And I think a lot of times, I don't think that we stop them from engaging. They may give you the most expensive idea they've ever come up with, and it may be something that financially you just cannot do, right? Which goes back to the problem that leadership has. I think sometimes the perception is that leadership doesn't want to say yes. Leadership wants to say yes, but if it doesn't financially make sense to the entire vision of the company, then it cannot be done. But I still think that we should encourage those conversations, because there may be a time when it does make more financial sense, and they can begin exploring how to do it in a more cost-effective way and still get to the same destination. So I say continue to encourage it, but always keep, no offense, the bean counters happy. Right?
Yeah, but I don't see, by the way, a contradictory here, because first of all, in my practical experience talking to industries or to whether it's a startup is sometimes easier, or a large corporation, you ask the guys, what is the vision of the company?
Yes.
And there's a lack of knowledge of the vision.
Yes.
Because vision is not connected to the profit at the same time, or to anything else. And it's not well spreaded. So this makes it quite difficult.
Yeah.
So there are huge companies that have a vision that is totally clear, connected to making profit and being successful. And sometimes nobody knows this vision. How you teach the people to think about the intention and in a manner that it reflects the business target or aim of the company as well.
The first question is, does the leadership know who they are?
Yeah.
Do they know who they are in the market? Do they know who they want to be? And if they don't have that that understanding just yet. Do they have a plan to become?
Yeah.
Because if they don't have that, your employees are going to be spinning their wheels all the time because they're just trying to figure out, well, this person is this, and so I think we should be that. And they're like, well, no, this person is this, I think we should be that. And the leader's going, let's be both, because everyone's our client. Everyone's not your client, right? Go to your client, focus to your client, and that begins with identity in the company and knowing who you are as a company.
And the further aspect that I might bring up here is, so we were talking about going on holidays. That was a very nice analogy. And I think I don't want to go with everyone on a holiday. So I think that would be a selected circle.
Yeah, you don't travel with everyone.
Yeah, not with everyone. Yeah, probably with you. Well, what would?
Yes, we have a good time.
So, but there are people in your company who say, I don't want to travel with this person.
Yes.
And then again, how important is the intention to overcome these probably hesitation, to put it in a very positive aspect, or rather non-sympathy about others. So.
And I think leadership deals with this a lot too, because you have some people that are like, this is the way we've always done it. I don't want to change. I don't want to do anything different, right? And then you have the employees that have to work with the people that don't want to change. I think you have to ask yourself what the cost associated is with staying the same.
Yeah.
What are you paying to not be as innovative as you can be? And then you need to find out if that employee is the obstacle, because I've never seen cancer improve on its own.
Yeah.
I've seen it improve with removal or with healing.
Yeah.
Either way, it's going to require some discomfort in the short term so that you can have the long-term results.
Yeah, absolutely, absolutely. Let me ask you one further question, if I'm allowed to. So, in order to set that in a context, so what is your role? I mean, I was totally motivated and inspired by the speech. So, but what is the business context in what you are supplying?
Money.
Yeah, you want money. Yeah. So, for what you want money? Let's put it that way.
So, Hybrid Manufacturing Technologies Global is a global supplier of DED systems, directed energy deposition, for those of you who don't know, which I'm sure everyone in here knows that. And we retrofit onto CNCs, robots, and gantries. My role is financial. So all sales and marketing efforts for Hybrid Manufacturing Technologies Global. So I have plenty of the people that say, I don't want to move my boat.
Okay, thank you. Yeah, you have to create more desire.
We're closer to the sea,
and you are the right person, that's for sure. So, ladies and gentlemen, I don't know how you feel. I'm highly motivated, not only for the rest of the day, of the rest of the Formnext, rather I would say for the next year. So this was, I would love to have you with all my training so that I can bring the spirit that you presented today to the people that need to have this spirit. Thank you so much. Ladies and gentlemen, big applause. Liza Block, was a pleasure having you on stage. Thank you so much. Enjoy the rest of the day. Yeah, ladies and gentlemen, that brings me, talking about highlights, it's a perfect transition to Formnext highlights, because this is exactly what you can enjoy. And afterwards, we warm up for tonight's big event, the Formnext Awards, because I will have 3 finalists on stage here for a small discussion of what their projects are about. So you should stay tuned, but first enjoy our Formnext highlights.
10 years Formnext in Frankfurt. That means 10 years of innovation at Renishaw and 10 years increasing productivity in AM systems. If we have a look at it, at the journey, we talk about high efficiency quad laser module, then Tempus technology, Libertas long life filtration system, just to name some of these milestones which make AM technology today extremely productive. Let's have a closer look to it. Hey Chris, how are you doing?
Bono, I'm good.
Great first day at the show.
Brilliant show, fantastic. Just what we've been looking forward to.
Excellent. This is here really Renishaw at its best. We have a whole process, additive manufacturing, milling with our partners from the company Chiron, and final inspection with our latest and new Equator X. But what I particularly like is our digital workflow with our partners from Siemens, where we design the part, we design the process, and then we implement it in one go into the factory. That's really fabulous. What about the 500Q Ultra? What's special about it?
So the Renishaw 500Q Ultra system is really highly productive, and there's a number of reasons for that. Number one is that it's got 4 lasers within a very, very small, compact footprint, which is really important for some of our high production users. It also then leverages Tempus technology. Tempus technology is patented process from Renishaw, which means the laser actually operates on 2 different layers simultaneously while the machine is wiping. So effectively, powder is being spread constantly while the lasers are still firing. This is an algorithm we've developed, patented, and is being implemented by many of our largest serial production customers.
Excellent, thank you very much.
Thanks, Rainer.
That was not it yet. We're looking here at our latest milestone in increasing the productivity of our systems. Hi, Luis. What is it about with Libertas?
So the first thing to say about Libertas is that it is a software product. So for our existing RenAM 500 customers, there's no additional hardware required. And as the name suggests, Libertas gives those customers the freedom to dynamically optimize their laser parameters across all regions of a geometry. And this is maximizing the quality that our customers have come to expect from Renishaw.
So on these parts we're seeing here, what kind of reduction of supports we're looking at?
Yes, so what this freedom means is that users and customers can basically now print with vastly reduced supports. So all of this fewer supports means that we are saving on material, but we're also improving the surface finish of the parts. And the reduction in supports also is a benefit for post-processing. Yeah. So we're saving time taking those parts off, which is having a positive impact on productivity and the environment. So these are a range of parts from different industries. We've got some dental, medical, aerospace, consumer electronics. And what we've got is a range of savings from Libertas. So from 60%, 80, 96, and this part has got a 97% reduction in support material.
And there are also builds now. We can build with Libertas. We couldn't even build without Libertas.
Absolutely. So on this particular one, where we've got 1 row of parts, that's because it wasn't possible to build it in a stack with the supports. Impossible to get the heat out. Once we apply Libertas, then we can build a whole stack. So this technology really opens up the applications for our customers to print parts that maybe weren't possible to print before.
So I think it's fair to say we maintain the market leader in ratio productivity to footprint of our systems even more with Libertas.
Absolutely. It's an addition to the Tempus technology that we introduced a couple of years ago. Now we've got Libertas, all aimed at productivity.
Excellent. Thank you very much.
No problem.
Pleasure,
Thanks,
as
Rainer.
always. We had a fabulous first day at Formnext 2025, and we truly enjoy our journey through innovation. Thank you very much.
You might have thought AM is all about big machines and raw materials, but it can do glam as well. We're here at Ledger's. Let's see how they can glam me up.
Hello, ladies and gentlemen, and welcome back here at the industry stage at Formnext 2025 for a very interesting panel, at least in my opinion, because we take a closer look at 3 of the finalists of the Ambassador Award, handed over tonight at our Formnext Award ceremony. And let me explain you a little bit the topic. So additive manufacturing does not grow through technology alone. It grows through people, and Lisa just showed it perfectly in her speech just right up front. And we need educators to close skill gaps. We need associations that build entire ecosystems, what we heard this today already. And we need researchers who use digital tools to scale knowledge worldwide. And the session, The Voices of AM, brings together the 3 finalists of this year's AM Ambassador Award, because their projects help accelerate AM adoption in very different ways, but with the same vision. More skills, more access, more impact. And today we will explore their initiatives. We take a closer look behind the scene, understand why they matter, and get a preview of what you will see later this afternoon at the AM Ambassador Award ceremony. Please welcome with me on stage, to my left, Irena Holzort, who is scientist and trainer at SKZ, das Kunststoffzentrum. Yeah, probably we have to elaborate on that a little bit later. Irena, it's a pleasure to have you on stage. Thank you so much. Then we have, and now it's getting, but I tried to do it in Spanish, Nayara.
Okay.
Nayara Zubizarreta, I don't know, it's not perfect.
It was
but
good.
Yeah, okay. So, Director of Adimat, Asociación Española de Fabricación Aditiva y 3D. Wow.
Wow.
Kind of. Yeah, I know, it's not perfect, yeah. So, and last but not least, Dr. Gustavo Melo, who is Senior Consultant and Research Group Manager, holding the chair of Digital Additive Production at RWH Aachen. Gustavo, I had you already on stage, and I'm again pleased that you joined us today. Thank you for being here. So, let's dig into the topic and talk a little bit about, what your projects are. So, Irena, what challenge in AM education does your project solve, and why it is so essential today?
Okay. Yeah, I think AM is a future key technology, but there is still a lack of training courses. So SKZ, in cooperation with the Chamber of Industry and Commerce, has developed a training course, AM technology. And I think it's very important to close the gap between completed apprenticeship and academic education. The training course concludes with a recognized state qualification, and it completes, and it will change the education part. So I think it's necessary to do this now. And not later.
And that's, by the way, something we didn't have before, right?
Yeah,
there
yes,
was no
of course.
real
Yes.
AM education level at this time.
Yes.
Very good. Thank you for that. We come later back on this one. Nayara, how does your work at Adimat strengthen the AM ecosystem and help accelerate adoption? Because I know that is super important, and Spain is really driving fast at the moment. So what are you actually doing there?
Yeah, we are a group of 100 companies.
Yeah.
And then what we do basically is to put those companies to work together.
Yeah.
For instance, here we have a booth that we organize from Adimat with 10 of our members. And this is a solution to give more visibility to the companies, because some of them are very small. So this is an strategical solution to go all together and to go faster and arrive to...
a high level, basically.
High level,
So you make them visible, you make them able to appear visible at a fair, not only in a fair, but also in the business environment in Spain, right?
Yeah, like globally, and also in Spain, we put them to work together in different projects, and we give them a lot of visibility, provide some events to work together and to give visibility to the additive manufacturing in the industrial ecosystem to implement the adoption of it.
Yeah. We talk later a little bit also about verticals, especially in Spain. I would be interested where additive manufacturing takes place the most. That's super interesting. But first, let's come to Gustavo. Gustavo, I'm super happy that you're here today for your topic, to be honest, because we had you several times as an expert here in this panel, but this time you can really talk about your project, what I really like. So how can immersive and digital tools that you're using can make AM trainings more scalable and accessible worldwide? Because this would fit to both the other finalists in order to push their projects.
Exactly. From my side, thanks for inviting me. In Aachen, I'm originally we are from Brazil. I'm from Brazil, moved to Aachen, and I saw that strong background and strong know-how that Aachen had, and still have in additive manufacturing. So that was my hook point of why not publish or go in a direction of PhD and research of fostering the knowledge transfer in additive manufacturing. I saw that as a barrier, and then that was my PhD topic, and then deep dive how we could not only run to keep the pace of the technology, but use technology to share the knowledge of additive manufacturing. And that was my hook point of my PhD and my PhD topic. Why not explore augmented reality, virtual reality, so immersive technology to make it independent of time, independent of location. So be a way to express and share the knowledge, also tested knowledge that's usually really tough, as we were discussing beforehand, in a way that could be reached beyond the borders of the country, beyond the borders as well. One hook that I got there was the machine learning aspect of it. So I monitor the labor market, so the job advertising that we have in the market, map it more than 10,000 jobs, and then from there, train the algorithm to understand what are the skill sets that we should tackle, not only specific in the region of Germany, but in clusters, to understand it's really dependent on the specific area where the technologies apply. So this is the approach that I come on, and really glad to be here and talk a little bit more about it.
Just to make that a little bit clearer in terms of usage, okay? Because you use VR and AR. So how can I imagine that? Let's say I want to step into the technology. Do I get a training via VR and AR, or it's rather I be able to use AM via VR and AR? What is the project about?
In Deep Dive, we have screened the whole process chain of additive manufacturing from design until quality assurance, to understand what are the sweet spots that we can use augmented reality and virtual reality. And then, for example, we developed for design for additive manufacturing some trainings that we can use with augmented reality glasses, but also with cell phones. So then can be reachable for different people in different level of social fairs. So that was one approach. In VR, for example, machine operation, machine familiarization. There was a situation during pandemic closed it, the whole market, and then we still needed to train people. Once it's open again, we have the machine on site, so we could pre-train all the operations or the operative people that are going to work on the machine before the machine arrived. So the ramp up was much quicker because of the VR training that we applied.
Very good, very good. Irina, you closed really a gap.
Yes.
We must say, because so far, and that's what I experienced over the last year, we mostly were talking about university education in regards to additive manufacturing. And so, as we discussed up front, you bring now, let's say, a technician into this industry, and you give him the chance to have an education dedicated to AM. What is the precondition a person must have to do this education? That would be interesting for me.
I think it's...
sorry for just adding, do I need to have a pre-education to start with, or could it be my son getting out of school and starting this education?
Yes, you need a closed apprenticeship, and then you can start with this education. I think companies works with additive manufacturing, but they don't have enough trained personnel, and that's also a big problem in this area of the field AM. People set up the machine, prepare material, or remove parts of support structures, do so without knowing the basis. And I think knowledge is the key to success in the technical level. Yes.
Very good. Naya, it brings me to you. I mean, you're bringing small companies visible here to the fair or in your ecosystem, but at the same time, let's talk a little bit about the skills and talents you need to do so. How is it in Spain? Is there a great demand or great interest of the people in additive manufacturing, so that you have a steady flow of people reaching or getting into the industry? Or is that a topic that you really, as Adimat, you have to focus on to get more interest in that topic?
Yeah, of course, we have to focus on it because as it's happening everywhere else, we have less and less people interested in working in industry, but not in industry only, but there is less young people. And then we need to encourage these young people to come to the industry, explain that additive manufacturing is a high-tech sector, that they can achieve very successful careers here, and we are working a lot on that. We have an institute that have specialized courses on additive manufacturing, and we have a lab with industrial machines where we train students to use additive manufacturing equipment, the same equipment that they will find later in the companies that are part of Adimat, of our ecosystem, and they will have to manage them, or they will have to sell parts done in those kind of pieces. And also we are working a lot with our companies in giving visibility to the business cases that are successful.
Yeah.
And then we are doing quite a lot work there, giving visibility to those case studies so that they can understand what's behind the technology, what can you achieve with that? Because we have been like the last 10 years talking about the technology as how cool it is, how cool is this process, but now we have to focus on the real application, and we are working on industry, and we need solutions for those end users. And this is our focus, and this is where we should move forward, I think.
Irina, just one more question for you in this regard. Naya was talking again about students, and we are talking here about the technicians.
Yes.
But again, to bring somebody in, it's not a matter of age that's really important. Is this training that you develop also addressing the elder generation? So I would consider myself as the elder generation. So if I want to step into it, would that be an education if I had worked as a technician before?
Yes, of course. So in the actual training course, there's also a man who is your age.
Now it's getting dangerous. Now go ahead. No, feel free.
Yes, it's open for all. So I think young people and older people they work in the field AM. Yes.
I must, Gustavo, that's a question for you, because you have been using AI in your project. Today, this morning, I heard an interview with our very well-known person who is producing, or who has a big famous car brand and talks a lot about future. His first name is Alan. And he was saying that in 20 years, jobs or doing a job becomes optional. Because of the use of AI. And I mean, we heard a lot about AI here in additive manufacturing. Do we really need to educate the people? Because I hear all the time about automated design, automated use of AI in order to create products. Do we really need that in the future? I know that's very provocative, but...
we can deep dive and then apocalypse scenarios, but I'm a big fan of combining AI and human intelligence. AI here is there to augment the intelligence of humans. So they combine there. So that's the main idea behind what I also approach in my PhD. It's rather to use AI to understand the labor market, and from there, get the skill sets what is needed. For sure, once you have digital tools, and you use those digital tools, we start to collecting data as well. And this collection of data could be helpful as well to guide some new trainings in the future. So this is also the idea of merging both, but I'm definitely a big fan of AI as support, as an enabler of human intelligence. I just see the new, I have my base of my PhD, but I just see the next steps and where we're going right now in the development. It's ready to have the digital assistant, but that's why it's digital assistant, and it's there to interact with you, as we are now more and more interact with AI tools like ChatGPT. So we are interacting with that, and we're getting more productive in some parts, and we see some parts like bullshit. And then we rework and learn with that and improve in the next round. And that's my point of view as well in an AI world and how it's going to merge with our intelligence.
Very good, very good. Naya, you mentioned students, and you are focusing, let's say, the people that want to go into technical education. But shouldn't we start much earlier? And this is a discussion I had last year with a visitor of Formnext. If I think about my son, they're 14 now. Don't get me wrong, but isn't that the age where we need to start now? Because we're talking about a very, very digital industry. If we consider additive manufacturing, they are starting very early in touching it and using it. And I think that we are much earlier in the knowledge phase where it's probably feasible. Is that something you are considering?
Yeah, we are we think that we should start earlier in schools, like introducing 3D printers, like introducing technology that children know already that technology is important, that they can change things with using the technology. And absolutely, we are in. I mean, we think this is a place to start when they are children, and we need to have those this storytelling that we want them to understand about the industry and the opportunities that they will have if they choose in an industrial career path, right?
Yeah.
So if when they are 14 or 10, they think they are going to be YouTubers, then the chance is gone. I mean,
the challenge will be that they all dream about being YouTuber or Instagram influencer. That's basically the problem. Probably in additive, that would be nice. Yeah, so talking about Spain a little bit, you hear now Irena is doing this training program. Is that something where you could work internationally together, or are there single initiatives in Spain regarding these topics? Because right this morning in the morning talk, we had AM Europe here on stage, so they try to foster the AM ecosystem, and you are fostering the ecosystem in Spain. But is there already international cooperation in regards to education?
Yeah, of course. I mean, there are many initiatives, isolated initiatives in Spain, because each institute or university is trying also to have this additive manufacturing course or something, because the people stay in their region most of the time. So everyone wants to have, in the key regions of Spain, there are some studies that you can do on additive manufacturing. But then we are part of AM Europe. Indeed, ADIMAT's president is the chairman of this initiative. And we are in contact with other associations at the European level. And we want also to work together in finding the skill gaps and to have the same route, what are the skills that we need, and do this work together, finding the gaps of the skills that we need for the additive manufacturing industry in the next years, so that all of us can do a job then in our countries, but following the same kind of guidelines, right?
Yeah, and the kind of structure. So I mean, this would be a question for you. I mean, you had our TH Aachen, and I remember there were times where especially universities all over Europe compete with each other if it comes to certain areas of studies, but especially in additive, I would assume that it's so helpful to go into international conversations about how to set a standard for education. You did a lot of research on the skill areas and skill, let's say, frames that we have to consider. Would you favorize such a solution, or would you say rather focus on Aachen because I have to push Aachen? What is your thought about that?
I mean, it's rather to combine the competence of each area. We discussed before in IATA as well. Spain has a really strong part of tool making. It's quite strong. We have there in Aachen, so there is a lot of areas that we could share the knowledge. Aachen has a strong background in metals. On the other side here, they have more in polymers, and then again against each other, right? The really interesting point that I proposed as well, describing what will be the skill set for the future. When you're mapping everything that you have in the market, you start to cluster and understand what's being applied and less but requested by the industry. On the other hand, we do have some new technologies upcoming, and seeing what is the forefront that we should work right now, before the technology is there, ready, and you don't have the people, right? So this is the cat and mouse run that you stay and keep it. This is the future, and it will be quicker and quicker. So that's why the approach is rather use the data, collect the data, bring to experts, exchange with experts, try to give this vision to work on, and then don't have the skill gap at the end of the day.
Yeah, and I don't want to bring up the topic of war for talents. That's nothing we're going to discuss today. But Irina, I mean, Gustavo tackled a very important point. It's developing very, very fast.
Yes.
Not only the technology, but supporting technology like AI, if we want to consider it as. And I tell you, I'm a heavy user, but on the same time, I feel like I'm still too slow to keep up with and I'm doing it every day. Yeah? So if you take the training course you develop, how often you need to update it in the future in order to be up to date? Because this is sometimes the problem with education. You train something, especially in the technical field or industry field, where the industry says already, sorry, this is a nice basis, but we are 5 years ahead.
Yeah, in my training education program, I work with 19 experts of the field of AM, so also active in research projects, and the topics are always up to date. Because the knowledge comes from the education, from the research projects, and that's the way.
Okay, so keeping it updated all the time.
Yes.
So we have 5 minutes left. I need to mention the Formnext Award, sorry, because this is, I mean, we mainly invited you for the projects, of course, but I mean, what does it mean for you? Let's give a minute to that. You know, I mean, you are a finalist for the A Ambassador Award, and I don't want to highlight any of the categories of the award, but as we said, it's still super important to spread the word of additive manufacturing. This is what this award is for. What does it mean to you to be a finalist, and where came the idea to apply for?
I'm very happy with the nomination for the award, and when I can change something, then I would say education is the key to success, and invest in training and technical trainings and further education programs on AM in the technical level.
Yeah, very good.
Yes.
Thank you, Naya. How did the idea arise to apply for the A Ambassador Award?
Yeah, the idea was that we are celebrating our 10th anniversary. ADIMAT was established 10 years ago, so it would be a recognition of this 10 years journey.
Yeah.
And so that was the idea of
very good.
Going for the award.
Yeah.
So it would be a great recognition for us.
Let's see. I don't know the winner yet, so you can still vote, by the way. Yeah, Gustavo.
Yeah, from my side, it was a really sweet spot for my life itself, because I saw how important education is to change the path of a career, to change the path of someone. And come from Brazil, moved to Germany, I saw how was important education to get it and arrive in a career that I still have today. And then that's why I kind of select that topic of knowledge transfer and education for my PhD topic. In specific deep dive on that. And then I saw that was a award regarding training education, knowledge transfer. I think that's exactly what I should apply for, to foster and show. We do have to create some ways to spread the knowledge in a scalable and more effective way, especially now that technologies are evolving so fast. So this is one of the major goals, and to show here and get some awareness as well about my topic, PhD topic as well.
Very good, very good. One very interesting thing we sometimes do not have time for, but especially in the A Ambassador environment, would be very important for me to know, and probably for the audience as well. What was your individual motivation to step into AM? Because we're talking all the time, we need to get people in there, and so. But I think my main driver would be a story from a person that stepped into, and you stayed. I mean, I don't know how long do you do ADIMAT now?
10 years.
10 years. So you see, So you see, there must be some certain. What brought you into AM?
For me, I was working in industry in the Association for Machine Tool Builders in Spain. And this was a new project that was offered to me to lead. And the technology was so cool, so I couldn't say no.
Okay, so you were kind of addicted right in the first place.
Yes.
What material, what technology was it, if you remember that?
Which technology was
it? Yeah, what kind of?
The additive manufacturing technology to establish the new association for additive manufacturing in Spain.
So in total,
this was what they
cool.
offered to me.
Yeah.
And so it was really exciting. that back in the time I didn't have any clue on 3D printing. So
that's a good one. Yeah,
I came to Formnext, of course, on 2015. It was the first year of the exhibition as well. And then I understood many things, and I say, okay, this is a good place to be.
Yeah. Ina, you have a background in plastics, basically, right?
Yes,
This is where you,
yes,
where
of
you
course.
are, not have been.
Yeah.
Are. Or you have been is the right expert.
Yes,
Yeah.
yes.
So how did you get in touch with AM?
Yeah, I started in the research and development department with AM, and then I want to change in the education department, and saw a lot of problems on this second level at AM, and so here I am.
Nice story. And you can't get loose, right? It's nothing where you can leave again. Yeah, that's really a problem. Gustavo.
Yeah, from my side, it was working especially in international collaboration between Brazil and Germany, and technology and knowledge transfer. And then I really saw a sweet spot since I'm a metallurgical engineer as a background, worked many years in steel making, as well oil and gas. And I was totally fascinated the first time that I saw it, additive manufacturing, LPBF especially. And then, okay, this is something that indeed has some potential in the future to really change the way that we design, they really change the way we produce. And then that was like click. Yeah, let's select that in a sweet spot between Germany and Brazil for knowledge transfer, and from that on start to write proposals and join the career in additive manufacturing as a connection, connection of both countries.
Very good. So first of all, let me express my appreciation for your entering the Formnext Awards, for the A Ambassador Award, but mainly for your work. But because regardless of the award, this is so helpful that you push AM, because I'm the same addicted as you. So thank you very much for being our guest today. Big applause, ladies and gentlemen, for our panelists here today. And yeah, I would love to say it's only one time more sleeping, but it's in a few hours already. So I'm very excited to open the envelope and tell you who the winner is. So ladies and gentlemen, you should not miss that. Before that, you can relax at least for a little bit, because we are going now into our lunch break. So enjoy your lunch break, but stay tuned. Latest at 2:15, you should be back again on the streets or streams and back again here at the stage, because we have a wonderful program to come. And of course, don't miss the Formnext Awards. I'm so much looking forward to it. See you later.
Oh, come on, Lisa. Shut up. This is ridiculous.
So, what have we got so far? Any brilliant ideas for the anniversary?
People, program, process, popcorn, and party.
Pole dance.
Professionalism.
We show people. Professional people.
Smiling people? No, please. Not just a parade of happy faces.
People,
Talking about where they're from.
No time for that. And how does that connect to additive manufacturing?
Right. Because they're holding something. A part. Cool design. Something 3D printed.
Let's hope your enthusiasm can save the pitch at 11. We'll need all of it.
Let's show the products. Think of commercials. For car porn style. This is gonna be hot.
Why not add some bad taste erotic music?
Let's not.
Yeah, let's not.
This project is killing me. It has to be something special.
Something special. Something specific. Specific industries.
Aviation and aerospace? Lightweight is important to them. Engineering and construction? Definitely big ones in 3D printing. They'd love to see that too. And jewelry is on the rise. They sure expect more visitors from this sector. Don't even think about bringing up Paul.
But he was the secret star of the last exhibition.
Still can't believe it.
What about the faces behind Formnext, the organizing team? We have event management, sales and customer care, marketing and communication.
Exhibitor services, new sales, and the management. With Christoph, Sasha, and of course, Petra. Though I can already hear her say, I don't think this is gonna work that way.
Can we cover the entire process chain?
The entire process chain?
The entire process chain.
Epic film.
An epic film with huge machines and massive booths.
In slow motion.
Awesome.
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 That's literally every other trade show video.
Let's break expectations and we finally deliver something truly fresh. We show how AM works in production.
Done that already. Application Insight at Audi 2023.
Or we show the unique benefits of 3D printed parts made of special materials.
Done that already. Technical Ceramics, Exhibitor Focus 2024.
Or we dive into different 3D printing technologies.
SLS and SLA Technology, Exhibitor Spotlight 2022. Done that already.
Done that already.
Yeah, we do that every year. We need to nail this. We need to deliver something truly special.
So what do you suggest?
How about we finish with a conga line?
Oh, come on, Lisa. Shut up. This is ridiculous.
Woke up this morning. Now watch me step. The week was murder. I'm gonna get rid of the stress. I'm feeling lighter. I'm finally feeling like I can breathe. The night is calling. Tension, gonna blow in the breeze. We're rolling downtown. We're grooving to the sound. We're rolling downtown. The weekend's here and it feels so right. I think I'll break the skins out tonight. I'm gonna go out and have a good time. Ain't nothing
Welcome to the afternoon of Formnext live stream here at Formnext 2025. Welcome here at our booth and welcome at home in our live stream. I'm very happy to have you back again. Yeah, yesterday was full packed with information here from our booth and on the fairground overall. And this morning, for example, we have business cases, expert presentations, and so on in our live stream. If you like to watch them or if you missed them, you can watch them anytime in the Formnext Media Library, or you go to LinkedIn, for example, where you watch us right now, and then you can scroll and find all the live streams recorded there as well. So make sure that you do not miss anything. And this afternoon, again, you can expect a very rich program here on stage. And first, we want to dive into the aspect of designing for additive. And as a special highlight, the new Formnext Awards will be presented this afternoon. Make sure to watch these as well. But before we start our next expert insight session here on stage, I may have the one or the other tip for you. It may be useful when you want to polish up your career a little bit, because here in Hall 11.0 at the booth number D29, you can find a free job application, a photo shoot today until 4 o'clock. So that's a direct exchange with potential new employers at the trade fair and the job wall to find some vacancies over there. And even there is a free career consultation today also up until 4 o'clock in the afternoon. So maybe this is good for you to start your career or to boost your career in AM. Yeah, but now let's start our session. I think engineers here who want to find the perfect design for their certain tasks found the right place to be here at Formnext 2025. And an overview of the opportunities, but also about the challenges for product designers in 3D printing will be given by Tobias Heenwader. Tobias, good to have you here with me on stage. Tobias is CEO of ID Design, Produktentwicklung in Munich, and he brings his knowledge of industry product design to stage with experience in a complex area like UX design. And he has, I can tell you, some very, very interesting examples you never knew before when he shows what can happen when you have the perfect design and nobody wants to buy it nevertheless. So Tobias, the stage is yours.
Okay, thank you and welcome everybody. So my name is Tobias. I'm an engineer, but I run a design company. And we emphasize that our industry designer really understand the production technology they use in their product design. And so the subject of today is challenges and opportunities for product design in 3D printing. So we start with Halloween stuff and we'll go to Christmas. You will see later why. But first, we are a normal design company and we use 3D printing in our daily use, from small serial production to prototyping to UX research, ergonomic studies. So that's normal stuff you see everywhere, and I don't want to talk of any of that. So first, I want to start with challenges. And quick question, who recognizes this animal? Anybody? It's not an animal, it's a 3D printed part. And the reason why it looks like bones is because of topology optimization. And you have the same general principle in topology optimization and in nature, that you add stuff where it's needed and remove stuff where it's not stressed enough. And for exactly the same reason, you will get an example here from Fusion 360. You get a motorcycle swing arm that looks really like, yeah, bone structure. Similar problem also coming from topology optimization is structures, they look very thin. From an engineering standpoint of view, they are stable for sure. But the human feeling for it is really that it will break. So we have to take care of that as well. So we made a really short example. In the left upper area, you have the topology optimized example, and we show you 3 stages where you can get away from this bone-like structure design. So first off, you can start with the refining, we call it, where you get rid of all the very thin structures, all the not smooth out surfaces. That helps. Then you can add a little bit of design edges. You can see in the right bottom corner, you can see these design edges you also see in cars. That helps to bring it even more away from nature and more to industrial design. Or the easiest solution is just hide it. Give it a skin, like every human has. Hide everything, the bone structure, under a 3D printed skin. That's also part of the part itself. And I want to show you the 3 different design levels in real examples. On the left side, you really can see the original, perfectly optimized engineering marble level of a part. Then it gets refined in a different case, and then on the right side you can see what happens if designers and engineers work together, so that you get really a product that doesn't look like bones anymore, and it's more like a really designed part of the motorbike, and also fits to the other parts of the motorbike as well. The second problem we have as designers with 3D printing is trypophobia. That's the fear of certain types of holes. Like 26% of the population have it in a small form, 12% have it in a strong form. And the reason why humans don't like these patterned holes is they are connected with parasites in your skin. So a little trigger warning, next picture is a little bit disgusting. So that's where it's coming from. And the problem we have in 3D printing is that it's very common filler structure. So you can design a 3D part. From engineering part is wonderful. You present it to your customers and they just see it and really disgusted by it. And you will have like 10-15% of the population. And for this example, I want to show you a 3D printed helmet that made exactly this mistake. Engineering-wise, it's perfect. You have a lot of airflow going through the helmet. Protection is perfect because it's copied from nature. But you have exactly this problem of trypophobia, that some of the population will think that you already had an accident, and a quite severe one. So we recommend go away from this nature-like structure, go more into this industrial style, and try to hide the principles you got from the computer designs, because they also work. And even for this example, if you build it, print it, test it, and you see, okay, my honeycomb structure isn't really as good as my original design, then I would recommend at least hide it. Put a small skin over it, but don't show it to the customer like this, because then you have a Halloween requisite and not a helmet. And if you have an accident and somebody finds you lying on the floor, they will call the priest and not the ambulance. And now the swing to Christmas, from Halloween to Christmas. It's almost Christmas in a few weeks, so it's Make-A-Wish time. And in general, on this whole area of 3D printing, we as designers see the problem that if I talk to anybody, they tell me about the engineering, about the support they have to print, of the removal process. But we as designers really try to think from the totally opposite direction. There's a very famous quote from Steve Jobs. You've got to start with the customer experience and work backwards to the technology. You can start with the technology and try to figure out where you're going to try and sell it. And we really want to emphasize that today. So we showed you a few examples. All these pictures are AI renderings we really made just for this presentation. But that's where you can see the problem. If I would be a person and I like some jewelry, I could make today these pictures, and then I go to a company where I can change them from picture to 3D. Then I can go to the web and search a company who can 3D print them. Then I get a quote and so on. And in the end, it's a very, very long process. But what the 3D printing community as a whole is seeming to forget, it's about the customer. And he doesn't care about your problems as an engineer. He doesn't really care, not at all. So we really want to emphasize that you start with the customer. Who is the customer? What does he want? And so during the last few weeks, as preparation for this talk today, we really ask our family, friends, colleagues, what would be an amazing scenario where you can imagine that 3D printing is really moving more into the B2C area so that you can really create some value. And the problem with most of the people we talk to is that they don't have that insight, neither in design, nor in getting quotations, nor getting the 3D files. Everything is too much. So what they want is a website that understands them. For example, imagine a website where you can put your face, say, okay, I have marriage tomorrow or in 1 year. You put up your face, tell the AI, please change my face to a bright face, and then give me some example of jewelry I could wear for that day. And then I want that on that website, there will be all the processing behind of the conversion from picture to 3D, to quotation, to delivery date, to cost, to payment, everything. Because what I want is that I have a personal designer, a personal artist who takes care of me. And I know that the technology behind of all of that is very complicated and will take a lot of time, and everybody is thinking from the engineering side, but that's what I said, and also Steve Jobs said, the customer doesn't care. Start with the customer. Ask what does he want. Second example, imagine, and there are a lot of beautiful lamps lying around here in this area. Imagine that you can take a picture of your home, your hotel, anything you can imagine, and then just ask an AI, okay, what would you put there? What kind of design could you imagine fits into this? And then you really have the even amazing, getting bigger and bigger amazing technology of AI that can consider all these styles of your home, of your furniture, of lighting, of color, and then ask it, what would you prefer? And then you just get one sample and another one and another one. And from this point, you have a nice idea, but the process to the finished product is very long. And you cannot, as a normal human being, do it because it doesn't make sense. They don't want it, and they sometimes don't even know it. So that what we thought would be really amazing, so that everybody gets a connection to 3D printing. And it doesn't work that one company here at Formnext will develop such a platform, because then you only have one technology, one kind of product that will be able to 3D print. So that has to be a platform for everybody, for every 3D printer. It doesn't matter if it's for lamps and made by plastic, or for cutlery, for I show you a few other pictures. For example, you could take a picture of your table, of your dining table, because you want new cutlery. And you didn't find anything you like on the internet. So where do you go? There's your famous website. I don't know the name of it yet. So, but you know, they maybe can help you. So you go there, prompt your pictures, show what you already have, what kind of plates you have, what kind of style your whole dining area is, and then you design your own. And then this website knows, okay, I have a 3D printing, metal 3D printing company who also can do the grinding. They will get the offer, they will produce it, and then send it to the customers. Same for vases, same for door handles, same for even for real glass lamps that are very heavy, very complex. But what we need is a website that's their first point of contact, where you can start with an idea and then it takes care of every step afterwards. And even for art, I know that's a tough area, especially with AI, because people want to buy real art that's made by human. But sometimes you don't care so much because it's just a void filler in your house, in your garden, and you don't have your personal Da Vinci at home because you are none of the Medicis. But you can go on this website, say, okay, I want a sculpture in this style, in this form, in this coloration for this purpose. And then you get ideas and ideas, because you can print as often refresh as you want to. And if you found your way, then you can upload it, make it in 3D files, and in a few minutes you will get quotations, delivery dates, and so on. Same with benches, same with picture frames. So imagine everything. And what we really want is that people, especially B2C customers, have the feeling that 3D printing is for you and nobody else. So that's a personal connection, and it's really important that they have the feeling, okay, that's now shipped to me and nobody ever else will have it. And thank you.
Yes, thank you very much, Tobias. You're a little bit ahead of time.
Yeah, that's very fast.
Oh, well, that's very fun. So I have more time for questions for you.
Sure.
Let's we start with a Halloween aspect of what you showed to us. Yeah, maybe you.
Yeah, sure.
You can switch into this one.
Bone structure or this one?
Yeah, something like that. You know,
let's start with the bone structure.
Is it? My interest is in knowing, is it just your approach to the topic, or did you do any research? Did you get some? How did you collect information from end users or from customers?
Okay. We try to find a subject where we can tell you something new about the views of industrial designer on the work of engineers. And we really try to find a new, and we talked with a lot of customers, but unfortunately they're mostly in aerospace and in aircraft and not in consumer products. So these samples are very unusual, to be honest. So like 80-90% of this topology optimization doesn't matter for design, but we really wanted to show that if you, for example, build a bicycle frame and you ask yourself, why doesn't it sell? That's just a hint from our side. That could be the problem, because it looks morbid, looks like skeleton, like it's dead. It's just, maybe change it.
But you, for sure, you said it, and it was understandable what you said. But doesn't we need we surely would need a better numbers and figures about how the people assess these designs. So is there an institute or some research going on or something like that?
No, we haven't done that yet because we already talked with software companies who use this topology optimization, because from our point of view, we have to start there and ask them if product design, these ideas I showed you, is even possible. Because if you add too much weight to the production process for your product design, let's say like 20-50% of the weight, you will also increase the 3D printing costs. And so we didn't do any research, but we already in contact with the 3D software companies and talk to them if it's even possible.
Okay, so maybe that would be the next step when companies do their design, that they have the possibility to check on a valid base if it's really doing the scaring effect, or having the scaring effect. You mentioned that we have a neutral approach to this topic. Because the one says, okay, I like it, like a bone, like a head bone, and the next one says, oh, I'm really afraid, but you never know.
Yeah, but that's actually the point of the problem, because engineers, especially if they are in this area, we found out just by talking to them that they are so fascinated by the technology that they don't see the problem anymore. And they're like a surgeon who really shows you how amazing an eye works if you cut it open. And you are just, Jesus Christ, where did you get the eye from? And why you show it directly into my face? And it's similar with the engineers. They don't see the problem anymore. So you have to really take a step back and show them.
Maybe there is a research institute who covers topics like that,
that
and
would be amazing.
that would be good to have a discussion with you.
Yeah.
But let us, before our time runs out at last, I want to ask you. I very much like the idea about the website being built, and I do a little bit of sketching, or I ask my AI, and then I go to the website, and 2 days later it's delivered. So, but how do we get the website like that? Who would be the partner? Who would be the company? Or what is your idea in get it started to get such a service?
That's a good idea, because I really wanted to show you that we see this problem, that there is no focus on the customer. There's so much focus inside here on the production, but not on the customer. And think of any product you want to buy. There will always be Amazon, eBay. They're directly connected in your brain. There you can get it. So we really need this website where it's connected to everybody, where you can get special 3D printed brass parts. Doesn't matter what.
But what's your idea? Who can program it? Who could be the company or the entity to provide the community with such a service?
Somebody who wants to be really rich.
Okay, we have to talk to Jeff Bezos.
No, it's a software problem company, so it's not our specialty as product designer, but we would recommend it. And it's you have same. I don't remember the name of the Etsy. Etsy is a very famous company where you get handcrafted stuff. Everybody knows, okay, if I want to have a special present that's really handcrafted, I go to Etsy, because you cannot get it on Amazon. And we believe that a very similar approach with 3D printing would be possible, but of course, developing this web page and getting everyone into it, every 3D printer, every surface finisher, to be part of this thing will be a huge challenge, but I think it will be worth it.
But you would stand there as a company and as a person to partner if somebody says, "Oh, good idea, let's talk." So you would be available for partnering or for helping to get this one to life.
Yes, sure, but we cannot be the only ones, because we are industrial designers. But as I've shown you, there also is a need for jewelry design, and there's also a need for lamp design. So there will be a lot of different designers who will be necessary to guide this process, so that you really can test it, user experience, and say, okay, now I'm amazed. And now I go to this web page, I want to have a new lamp, and I can change the color gradient, I can change the color of the lamp itself, for what mood it's used, for
I can adjust the material and so
everything.
on. Yeah.
And then I just can buy it.
Yeah.
It's just out of my hand into the buy button.
Put it in the basket, and
exactly.
it will be delivered. Yeah, that is a very good vision. I just want to emphasize that I'm with you on that project. Tobias, thank you very much for the insights and the short discussion. We will see you again at our panel discussion at 3:20. Then you will join us here on stage. But first, we have a short break. The audience, one applause for Tobias. Thank you. And first, after a short commercial break, we will have the next highlight presentation here on stage with the topic of design, and make sure to zoom in or to stay.
We're here at the FiberSeek booth where we are going to be exploring how fiber 3D printing is evolving. Let us deep dive into how FiberSeek is empowering engineers to build, to experiment, as well as to evolve.
At FiberSeek, we're bringing the world's first consumer 3D printer that print continuous carbon fiber. So which means it gives desktop printing a metal grade strength, so it's not restricted to like toys, but like functional parts and use parts. You know, for engineers or like even makers, right, when you think about printing strong parts, you automatically think about metal. But between metal and plastic, there's such a thing called composites. And with this new product, you can print composite parts at home, at the office, and it's affordable to every single engineer. Now we're releasing this power to like everyone, to every engineer, to every maker. So I think it's gonna bring a lot of impact to the whole manufacturing industry. More unique is at a price point of like 2,000 euros, and you can print the continuous carbon fiber, which was once like tens of thousands of dollars. The machines are also live on Kickstarter, and so it's the best time to get them with the lowest price and with a lot of like packaging giveaways. So please like stay tuned.
There you have it. If you would like to explore the world's first consumer continuous carbon 3D printer, then head over to the FiberSeek's stand right here at Formnext 2025, or better still, visit their website.
The DAN Lab is located in Portugal, north of Portugal, in Guimarães. We are located in the campus of the University of Minho, and we are a laboratory of additive manufacturing, but we have other technologies like subtractive manufacturing or forming manufacturing, and all the products that you can see in our booth is made by us. Design, all the product is made by our technologies that are located in our laboratory. So you are invited to see what we have made here for the Formnext. Our mission, our vision is in fact to help the small and medium companies, in particular in Portugal, but we want also to grow up and to have collaborations with other companies in Europe and to make networking. I'm very proud of my team and the products that we develop with the collaboration with different kinds of industry, from different sectors, from automotive sectors, health, aerospace, tooling industry, and shop floor in different kinds of industry. So don't forget and visit us in booth F59 in Hall 11.
Celebrating 10 years of Formnext this year. The 11th has obviously already started. Make it safe, make it AM. Bye.
Welcome back to our session, Formnext Expert Insight, Design of AM, here at Formnext 2025. Good to have you here, good to have you on the live stream, and good to have you here at the booth. Yeah, end users are still overwhelmed by the various solutions and possibilities additive manufacturing can offer. But how to sort through these? There are so many of them, and how to get a start into the design. Our next speaker has found an answer to this question and offers a first stop for interested users. Jonathan Rowley. Jonathan, good to meet you. Jonathan is owner of Additive Companion, and he shows in his presentation a way to find you a 3D printing solution best fitting for you. And you have brought with you so many nice pictures. Hope we get them all into our 20 minutes. But
I've been rehearsing.
I shut up and the stage is yours.
Thank you very much, Frank. And thank you to all of you for coming this afternoon, and for all of you, well, some of you I know who are watching online. A little bit about myself. My background is as an architect. I practiced architecture for 20 years in London before taking something of a detour, which my parents were horrified by, leaving architecture and joining AM. And I ran an industrial AM bureau in London for about 8 years, specializing in SLS. And this was during the heyday of this technology, where everybody was interested in 3D printing. Our phone was ringing off the hook. And I've had thousands of conversations with people at all levels who wanted to start 3D printing. And the difficulty is that, these technologies offer solutions for an incredibly wide range of people. So the Additive Companion is something that I have, and what I'm doing now is that I now teach. I teach on a relatively new course at Central St Martin's School of Art, University of the Arts in London, which is an MA in Design for Industry 5.0, which is Industry 4 plus we care about people and the planet. And my role there is to help these MA students find their way through the jungle of AM. And Additive Companion is something I've been developing for almost 3 years now, which is fundamentally a historical archive of additive manufactured products with all of the characteristics listed. So, we're here on the Design for AM thread of the presentations. And I think it's pretty well accepted now that Design for AM is the prerequisite for the successful adoption of AM. However, DFAM is not a universal set of principles. DFAM is different for different technologies. And so there is one crucial question that you have to answer before you get into designing anything. And that question is, with 40 different types of AM, which one are you designing for? Which one is compatible with me and my product ambition? Can you tell the difference between any of these technologies? How do you decide? And so our answer is the Additive Companion, where you can find your 3D printing solution. Now, innovation is all well and good and is very exciting and is something that we're all of us here, de facto are interested in. However, to properly innovate, you cannot be unaware of what other people have done before, because otherwise you're not building on some very significant experience that has already been developed across this technology. It's 30 years old. It's not brand new. There's not much that people with my level of experience and beyond hadn't seen before. And it's important that people understand what's gone on before in order to build upon that. Now, who is this for? And I have a very glib answer to that. I always tell everybody it's for anybody. And at the end of this presentation, there is going to be a link and a QR code where I invite anybody to get on to the platform, first of all, to explore it, and then have the opportunity to engage with it. But who is it for? It's for enthusiasts, it's for students, it's for researchers, academics, designers, engineers, consultants, entrepreneurs. There is something in this for everybody to learn from. It is a collection of impartial and, most importantly, curated content. Anything that's on here, you know, we have we've vetted and we've weeded out the things that are really meaningful and have worked as projects, not just great world's first this, that, or the other, but projects that have had an impact and have resulted in a good outcome. And what it offers through this curated archive of currently over 400 case studies is the opportunity for you to discover new things that have been done before, to inspire you to look at things in your own sphere, to provide you with information, all of which adds up to give you the ability to decide on where to start with which technology. So at the heart of this are the case studies. And when you all visit the site, which I hope you do, this is the main entrance, really. There are different ways into this thing, but the main entrance is through the case studies, where we have over 400 case studies. Now, the idea is that we've got these curated ones. Once it's publicly available, I want case studies from everyone in the audience. I want case studies from everyone on all of these stands. Just because you submit a case study doesn't mean it'll be included, because it has to be sensible and elegant, and it doesn't have to be a game changer. And we will always publish new editions across our homepage. So here is just a sense of the array of the different case studies. You know, we've got 18 pages, 24 case studies on each page. And here we go, coming back to the top. First of all, you can start to search for things that you might have heard of. Here, we're doing a little search for Lego. What have Lego done with AM? And it pulls out the Lego projects. The other question is, what might BMW have done with AM? It pulls out the BMW projects. And then you can go into the filters. Highly categorized, different user types, different applications, different user levels, different materials, all of which you can switch on or off to give you a selection of projects that have been successful in the past that might relate to what you're looking to do. So I hope this isn't too tiresome. Let's look at some eyewear. I'm interested in eyewear, so that is pulling out all of the eyewear projects. And we can take a look at those and see which one of them looks like. There's fashion eyewear and there's technical eyewear, and I'm interested in technical eyewear. So I am going to land upon that one. Now, each of these case studies is based upon a top trumps card. I think all of us might have played these card games as children, whereby you've got racing cars and aeroplanes and all of their characteristics. And so we've got a picture of the AM part and then all of its characteristics, all of the ingredients that made up that part: designer, manufacturer, date that it was made, which is important, ballpark cost, what it cost to make one of those things. So, you know, if you were expecting to pay €1 for your iframes and you see that that object costs 30 euros, you know that this technology probably isn't for you. So it's as much about eliminating technologies as selecting them as well. So when it looks likely, you can then move on to the page that tells you about the material. This is SLS. And on the SLS page, we've got all of the other SLS case studies. So you can start to see, oh yes, this looks like my kind of thing. It's got the characteristics of that technology, how stripy it is, whether you need supports, a full list of the process, all the materials that it offers, all the manufacturers that make SLS machines, if you're mad enough to want to start off by buying one, and then service providers, people who've got that technology who can make these parts for you. And then you can filter that by location. These are all of the German service providers that do SLS. Now, once you're on the platform, you can favorite case studies and they will get stored in your profile. So there's like a scrapbook. Then you can go directly to the manufacturer that did that, was responsible for that particular project. So you can go straight to that manufacturer. So that is the kind of pathway that this offers you to select your right starting point. The second aspect of this project is that there is a community. And, you know, you are all welcome to join this community. You don't have to become part of the public profile. You don't have to make your profile public, but it's an opportunity for you to not advertise, but, you know, display your expertise. Which technologies do you know about? What are your interests within AM? Are you into aerospace or are you into art? And all of that gets logged on your profile, and people can start to find you. What software can you use? What technology have you got experience with? So you can start to find that. And this is how the community works. Yes. There we go. Now, you might reckon there are some faces in the audience who are already on this. All alphabetical. No one's paying to be top of the list. Anyone called Andrew is lucky. You know, there's a description of who you are and where you're from. This is the profile page. Now, if any of you go onto this, we need you to make a very simple profile. Just give us your first name and your surname, and that activates opportunities for you to contact us across every page. The key element about the community is that we are relying on you to pick holes in our information. If anything is wrong or if anything is missing, we want you to tell us. You send us a message, we ask you what your credentials are for suggesting this, and if they're bona fide, we will change it. So you are contributing to building up a reliable, consistent, dependable resource that benefits all of us. You know, here are the characteristics that you can activate if you want to make a more fulsome profile and maybe go public. At the moment, it's quite small, but we hope that it will grow. We hope that this is so useful that people will want to be a part of this. Now, if we look at my profile, you know, we've got projects that I've consulted on from the case studies. So I'm cross-linked with projects in the case studies. If you spot a case study that looks interesting, I'm attached to that, and you can be in touch with me if you want to do something similar. And everybody has the opportunity to do that. If you have any case study that's included in the archive, within your profile, that case study will be shown. You click on that case study, it goes in, you go into the case studies, and you're listed on the case study itself. So it's all about interconnecting projects, applications with the human beings that are responsible for them, thus building on the experience that exists in huge amounts across everybody here and within, the four halls here of Formnext. And, you can have your LinkedIn contact at the bottom as well. You can pick out people who know about MJF. You can pick out people who know about SLS. So it's all about finding your partners. Somebody has described this as kind of an online dating app for AM. I hope it's more successful than that. Okay, so here's an example of somebody from the community who has got several projects within the archive. And you click onto his case study. You're back into the case studies, and you can see his work, all the details of it, and there he is at the foot of the case study for you to be able to join his community page and get in touch with him. And as I say, that's totally up to Manolis whether that profile is public or not. He may not want to be bothered by any of us. If he doesn't mind, then that is available. And here we have, a little glimpse of the contact form that you can fill in on every page if you've got anything that you want to add into it, anything that you want to correct or suggest is not quite right. Okay, that's that. The third section is the resources. So we've got case studies, community, resources is all of the technology in the middle. Now, the way this works, you can go directly to any of these sections, either straight to case studies, straight to community, straight to resources. And that's divided into two sections. The top part, AM technology, is all about the hardware. Ecosystem is all about all of the companies and support services that surround AM. So this is the printer categories. You're going into the ASTM7 categories. These are the binder jetting technologies. These are all of the binder jetting case studies, advantages and disadvantages of binder jetting. And then from there you go into the individual binder jetting technologies. To find what you're after, find the manufacturers, find the service providers. The printer technologies, here are the 40 different types of AM that I described at the beginning, where do you start? And here you can start to, filter them out by material type, what category they are, etc. EBM. Those are the EBM case studies. They're the materials, they're the manufacturers. Then we have manufacturers' pages. Where they are on the planet, you can filter out Chinese companies, American companies, German companies, to see where they are, if that's important to you. That's the location finder. Then there's a listings finder where they're just alphabetically listed. And there's your company, and there's their profile. Nobody's paying for any of this. Everybody, if you're involved in this technology, you are part of this environment. This is not a subscription model whereby you pay to be in it. Everyone's in it. You just have to be, so that everybody's got the best range of choice to find the right technology. It'll end soon. You get the picture. There's a hell of a lot in here. There's a lot of data, and there's a lot of ways in which you can start to identify what you need. Materials, you can find them by, you know, their form, by their name. You know, you're looking for pellets. There are all of the pellet materials. That's the ABS pellet page. Those are the companies that produce hardware that can use ABS pellets. And you can go straight to them. Finishing. This is not complete. It will never be complete. It will always need to be updated. And we are committed to keeping this up to date. There's nothing worse than going to a resource and seeing that it's been dead for 6 months. And you know that there's no more live information on there. This has to be kept up to date, and we will do that with your help. What environments do these technologies need to be placed into? That's another interesting question. People will sell you anything. They don't care where you're going to put it, but you need to put these technologies in certain environments. So service bureaus, again, you can find the people that you need by location. In what country are you? These are all of the German service bureaus that I have. There may well be more. If you're not on here, let me know and we will add you in. Who does EBM in Germany? 3 companies. We'll zoom out. There is Frankfurt. That company is nearest to us who does EBM. And we can go straight to our nearest supplier. All that they do, everything else that they do, what finishing they provide, what other technologies do they offer?
Jonathan, would you allow me the one or the other question?
Yes. Can I just get to one interesting slide?
The last one.
Last one.
You want
I feared this would happen.
You want to
I
give
thought
the
I had
number?
another 4 minutes, but...
I want to have one or two questions. Tell me the number. The colleagues can show the number of.
Okay, let me just go through this slide.
This is the one. Yeah.
So we were very fortunate to have a lady called Alexis Dabby Saltmarsh on our proof of concept, and she is a tutor at College Gwent in Wales. She ran her motorsport and aerospace BTEC course this autumn, allowing her students to follow her normal curriculum with this resource alongside. And so we asked those students before they used it, how confident are you that you're aware of all of the possible applications of AM? And 76% of them said they were pretty confident. After using it, they were 86% confident. That's a significant increase. Before using it, they were asked how confident they were that they understood the full range of technologies. 71% of them were pretty confident. After using this, that went up to 91%. How confident were you beforehand to differentiate between all of the technologies? They weren't very confident about that. After using this, that doubled. And ultimately, beforehand, how confident were you making a decision about any of these technologies? Again, not very confident. After using that, that doubled again. So we think this is really very encouraging, you know, as a small sample size, but it's a good indicator of the impact that this can have in terms of helping people understand all of this and decide where to start. I could go on. But
I know, for hours and hours.
Yeah.
And the good thing is that you will join us on our panel, and I can ask my questions to you when you are sitting over there. Jonathan, thank you very much for this initiative, and stay here with me. Dear guests, we will have a short break, a short commercial break here on stage, and then we will have our design panel here on stage. So make sure to stay in our live stream and stay here at our booth.
Frank, they didn't get a chance to see the QR code.
I wish I could have a bigger boat. Yeah, it's quite decent, but I want an even bigger boat. Now that's more like it. AM, that's where dreams are made of.
I saw Dominic on LinkedIn, and he's doing really well in building a fantastic audience in LinkedIn. Yeah, I think with the challenges in Germany that we have at the moment in the manufacturing industry, we're really in need of fresh talent, of young people who bring the industry forward, and with that, of course, also the additive manufacturing community. And I hope he makes the most of this week.
Ich arbeite mit Firmen zusammen, die dann wirklich genau den Hexcode anmischen, den ich brauche. Für Anfang nächsten Jahres ist das Ziel, auf die Dachregion zu skalieren und dann zu schauen, wo man hinkommt.
Die Kamera läuft und bitte.
Dominik, du bist ja einer der jüngsten Gründer Deutschlands. Was interessiert dich an der additiven Fertigung?
Für mich ist das Coolste eigentlich daran, dass du bist in den Möglichkeiten wirklich unbeschränkt. Also das Einzige, was dich beschränkt, sind deine kreativen Ideen, und ansonsten es steht dir alles offen, und das finde ich halt wirklich sehr cool.
Wie bist du dazu gekommen? Also bist du morgens aus dem Bett gepurzelt und hast dir überlegt, additive Fertigung, das ist doch meins, oder hat sich das einfach so entwickelt?
Ich habe früher 3D-Spiele entwickelt, das heißt, ich habe schon früh angefangen zu modellieren, und dann wollte ich eine dieser Figuren, die ich erstellt habe, mal auf dem Schreibtisch stehen haben, und dann war halt das naheliegendste, einen 3D-Drucker zu kaufen, und so kam ich dann in die Szene rein. Also ich glaube, den Drucker habe ich so mit 9 Jahren ungefähr bekommen von meinen Eltern.
Und deine Produkte, haben die sich verändert? Gibt es da irgendwelche Visionen, die du hast, wo du sagst, das will ich unbedingt noch mal erkunden, oder spezialisierst du dich?
Ich probiere stetig, meine Produkte weiterzuentwickeln. Anfangs war ich ein einfacher 3D-Druckservice. Jetzt habe ich mich auf Werbemittel spezialisiert und immer weiter Dinge probieren, um dann einfach eine bessere Qualität.
Come visit Formnext. There's loads to see. Paris, the city of love. Formnext, the trade fair of love for additive manufacturing. Sometimes when people have been specializing in one area for too long, they say this, that, and the other is not possible. But not here. This is where young innovators make ideas happen. Hi, my name is Sylvie. Who are you?
Hi, I'm Rudy from
Hi,
Recycling
Rudy.
Fabrik.
Ah, what fabric?
Recycling.
Recycling. Okay, so you do recycling.
Yes, we do recycling.
Okay.
Recycling plastics from 3D printing waste streams and making out of this new 3D printing filament.
Okay, can you show me what you've got?
Yes, 3D printing filament made out of 100% recycled materials.
Okay, 100% recycles. Where do you get them from? What does it do, the filament? Where does it come from?
Directly from our customers. We source the material directly from the customers, who can send us their waste, scraps, everything they collected, also empty spools, and we are reusing it into making new 3D printing filament, and it's equal to traditional normal filament you can buy in other shops.
Sounds groovy. What are these?
These are objects to show the wide variety of our color collection. So it's not just brown filament when you recycle material, we also offer gray, ochre, terracotta, red, yellow, so many colors, over 60 or 17 colors we have at the moment,
Okay.
and I cannot count them anymore.
So whatever the customer wants, they approach you with their inquiry and off you go.
Yeah, we can do it.
Sounds good. Thank
Yeah.
you so much.
You're welcome.
Then I will see you around.
Have a nice day.
Bye.
Welcome back to our panel here, AM panel Design for AM at Formnext 2025 here in Hall 11O and on our booth D72 and in our live stream. I'm very happy to have you all here and that we can follow up our topics in design of AM. And today we bring together experts with various viewpoints here on stage, and I'm very, very happy to welcome following selected experts here on stage. Please join me in welcoming Jonathan Rowley. He is designer, educator, as we learned, and additive manufacturing specialist with over 2 decades of experience bridge in design, engineering, and material innovation. He has helped shape the way designers and manufacturers think about 3D printing. Today, he creates one of the most comprehensive AM case study archives we saw in your presentation some minutes before, helping companies and creators choose the right technologies for their ideas. I'm very happy, Jonathan, that we are here and that we can ask one or the other question. We had no time earlier. But going on to Dr. Tobias Heenwater, he's engineer and CEO of ID Design, a Munich-based design and engineering studio. Here he bridges the gap between designers and engineers by teaching designers about the relevant technical challenges of each manufacturing process so that designers can take these into account from the outset. His goal is that engineers no longer need to rework designs, and we had some examples from you. You brought with our buzzword is Halloween. Nobody wants to create Halloween with his design, so very good to have you here, Tobias. Sophia O'Neill from NURBS by DAFNA is a multidisciplinary designer merging the fields of robotics, automation and computation within the creative realm. And she brought some examples with her. Maybe we talk later about them. Her specific focus is on the intersection of the artistic with the technological. Sophia, good to have you here on stage.
Thanks for having me.
David Nguyen is a senior technical services engineer at Onshape by PDG, and he's supporting customers transitioning to Onshape's cloud-native CAD and PDM platform. David brings over a decade of experience across product development, mechanical design, and digital manufacturing. And there we have a lot of points where we can hook on. David, it's very good to have you here and to join us here on our panel. Thank you.
Great. Yeah, thanks a lot.
Yeah, so let's start. As you can see, we have a bandwidth of experts here for you, nearly as broad as a topic design for additive itself. But before we learn more about our guest and about the approach of the topic, maybe we have a quick look at what we collected here from the booths and from the fairground, what caught the eye of our camera team on the fairground when they think about design for AM. Roll the film. Oh, impressive. Not every example was from the fairground. Some are from other countries, what I saw. Jonathan, when you see these design, would they fit into your database?
Some of them are on there.
Some of they are there.
Some of them I wouldn't have, but some of them are on there, yeah.
How to decide which one would you like to have, and why did you choose the one you have?
Without wishing to become too esoteric, an awful lot of what people produce using AM I describe as shape making, just making shapes. And there's nothing wrong with making shapes, but it's not designing. Designing is understanding the material, the context, other elements that are going to go into it. It's a lot richer than a lot of what one sees. I give lectures across the UK on design for AM specifically for SLS. And why I love SLS is that it has material properties that if you understand them, you can make shapes that start to do things. And that's beyond shape making. There's nothing wrong with shape making, but if you can make shapes that then perform, then you're really starting to design and starting to take this to a whole new level.
Mm-hmm. And maybe not everybody watched your presentation. In a few words, you built up Additive Companion, a broad website where you collect the community, let's say, the examples, but also the people on the fairground here talking to each other, so the family and the companies. What is your the most important goal for you while you build up this website?
I'm quite naive. I honestly don't believe that there is anybody on this planet who can't use a little bit of AM to make what they do better. The problem is helping them find their starting point. Because if you don't start with the right technology, it's going to fail. If you're lucky, it will fail quickly. If you're unlucky, it'll fail slowly. When it does fail, people discount the whole technology, and it's very hard to pull them back from that. And that's why it's so important to start in the right place. And that's what my platform hopes to achieve. It's a broad resource that shows you where other people and what other people have used in order to achieve similar things to what you're trying to achieve, to minimize the situations where people start in the wrong place and end up getting nowhere with it.
Now we try to bring two people together to build a new service. Tobias mentioned in his presentation earlier that he would love to have a service, a website where everybody can access and choose the right design, the right material, the right provider, and put it in the basket, and it's delivered 2 days later. And we didn't find a clue how we can get a service like this. Maybe you two match with each other, and maybe your website could be a first step or helping achieving your vision.
Absolutely true, because his whole overview knowledge on all the different 3D printing technologies are really essential in the decision tree you need, from the picture, from the 3D file to the 3D printed part. And even if the customer doesn't see this amazing technology that's behind it, it's absolutely necessary. And it will be a huge challenge, so that, like Jonathan said, you design something that's not even meant for 3D designing because it's just shape building, and then make a part out of it. That's just the beginning. I'm more interested in the long run, where people can design stuff that's never imagined before because they are inspired by the possibilities of 3D printing. There are so many water taps I have seen, I didn't show in the presentation, that have the weirdest kind of shape, and you don't understand where the water is coming from. It just looks a metal, like a solid piece of metal, but it's enabled because designers understood the 3D printing process in detail, how the metal is molten, how the deep powdering process works, how tall you can make the tubes that powder still gets out, and stuff like this. And people have to understand it to get up with totally new ideas. And then we get away from what Jonathan said, just making shapes and then developing something really new that's only possible because of AM.
Okay, so maybe we come later back to the aspect that you add a basket to your website as well, and that we will have some kind of Amazon or something for 3D printing. So we have to work on that.
Sorry, maybe if I just can chip in something there. That sounds like the shapeways of the old days to me, you know, where you could just look through a library of existing 3D geometries and then choose your manufacturing technologies and would be sent to you. Maybe not necessarily respecting actually what is the best technology for you for there, but maybe I think also shapeways then change their business model as well. It doesn't really exist anymore as that marketplace, but maybe that's a business opportunity for you there in the future as well.
Maybe I think what Tobias has in mind is that the customer can kind of co-create something. What was on Shapeways was a product that you then ordered to be printed.
Yeah.
They had to choose that, and that is what they got. I think what you're talking about is the customer influencing the design.
Yeah,
because it was your example with the AI, right?
Yeah. Because I'm totally with Jonathan in that case, because I'm a little bit anxious that you put up 3D files in the internet and then people 3D print it, but that's not the reason why we use AM. We want to use AM for cases that are only possible because you use additive manufacturing. So customizable parts that just made once or twice. Most of the stuff I found on Shapeways, AM is not the right technology to produce them. It's just injection molded parts would be much more sensible. Sorry.
I'd just like to say that I might be coming across as overly kind of earnest and serious about this. If you look on the archive, there is a fun category. We have fun projects, and there's nothing wrong with fun, and that's that's where enthusiasts can be really engaged in this and hopefully evolve up through the system and then start doing things that I consider more serious.
Let's bring in Sophia in our discussion.
Speaking of fun.
Speaking of fun, no, speaking of people who do not have so much experience and to need a database like this or a service like Tobias mentioned, and that was what you told me, that your experience was that so many people in 3D printing industry have surprisingly little hands-on experience with the actual process of turning digital models into physical objects. Where does the experience come from? So where did you encounter this?
Well, one of the things about this industry that I love is half of it is industry making automotive metal printed parts, and a half of it is just people who love doing this and they do it on their own time with their own money and are so excited by it, and they push these design boundaries in their own ways. And we can learn so much from these hobbyist printers in shape, like articulation, and even material usage. And what Jonathan was talking about is that one thing that you make a shape, but it's another thing completely to understand how the material performs. And I've brought a lot of props with a lot of materials that perform differently. And I wanted to show you my Christmas ornaments. So regular shape, optimized for 3D printing, right? And regular multicolor silk PLA. However, when you make a shape that complements this material that behaves in a certain way, it's perfect. And this is design. This is where shape becomes a design. And another less popular...
Is it an example you created?
Yes, I created it. It's parametric. I created it in Grasshopper. So after multiple testing of multiple parameters and kind of trial and error, I came to this shape that is, you look at it from above and you have this like trifecta, and it's perfect. And it's not something that's perfect to me. It's something that's perfect for the average user, for someone who has never even thought of 3D printing. It makes them feel nostalgic, it makes them feel cheerful, and it makes them one step closer to becoming a 3D printing enthusiast, which is what we want, right? And then another example, also from my newest collection, is a material that behaves a little bit differently than the previous one, and it does horizontal swirls. And this was also trial and error because it's a trifecta, perfect trifecta, but here it heavily depends on the shape and how it transforms and makes these Christmas swirls. And it's fun, but it does its performance, which is its main performance is it has to be beautiful.
Is there some kind of asymmetrical weight distribution in that that's making it? Okay.
Exactly.
So, and all of that's disguised within the heart of it. I mean, it's fantastic.
Yeah.
There's a candy cane one.
It's so funny that if you're involved in 3D printing, it is the law that you have to do Christmas decorations. Everybody here will be working on their Christmas decorations.
And you start
I've learned
now.
a lot from my Christmas decorations over time. There should be a whole section.
I might disagree. I would say keychains.
Oh, yes. Okay.
Christmas
But this
decoration.
is season, yeah.
We even at ID Design we have a competition each year. You have to design Christmas ball, and the best one gets one holiday extra. And that's how we decorated our whole Christmas tree with 3D printed parts. So it's like she said, it's really fun.
Yeah.
It's not only about the amazing engineering you can do with it, but also about the fun. And I think the fun is important because from my experience is that good engineers start with Lego and now they go to 3D printing and then they become good engineers.
Yeah, maybe. I mean, here we're talking quite a fair bit also about, let's say, consumer 3D printing, people printing at 3D homes, doing their own 3D printing at home. And that's great, you know, because it's really opening a door to the technology, also to people that, that have no experience, no exposure to the technology before, you know. And so it is also fun maybe to just find these models on the internet and just print them because you feel like, okay, I have already created something by myself. It just came out of nothing. But people, they really say once they also start creating the design behind what they will be printing afterwards, it even becomes more rewarding to them, you know. And that's maybe also a little bit of a link to maybe Onshape that I'm working for. There's also free tier, you know, if you're a hobbyist, if you do your own 3D printing, this is where you can get started with some easier introduction to parametric CAD modeling. It's probably also a notch easier than going straight into designing with Rhino and Grasshopper like Sophia is doing there.
Well, there would have been a link a little bit later between you both, but let me give Sophia one question. What impresses me is that it's not about the design, just nice to look at or nice to have it in my sitting room, the examples you showed earlier, but it's about the design of the structure. So maybe you can give us a bit more insight about how hard is it for you to achieve it, or what your tools are. And now you think about, maybe we come to you later. Which tools do you use to make the design? And there I mean the structural.
My biggest tool is print settings. It's all about the print settings. Of course, it starts with the geometry and it has to be compatible with the limitations of FDM, which is the type of printing that I predominantly use. But the tool is print settings, and especially when you're working with filaments and materials that behave in a specific way. If I wanted to have more rigorous, kind of smaller swirls, I would change the geometry, but I would also make the walls thicker. So I'd have 3 layers, and then the filament would have less time to gradually grow, and it would be layer by layer. And vice versa, if I wanted one gradual swirl, I'd make it single wall. And those are design decisions that come with I don't want to say limitations, but within the boundaries of what you can make with your machine. And there are design decisions that you can share as a limitation, but they're also, I see it as an opportunity to shape my designs and to kind of express myself in a way that I can within relationship with my machine and my algorithms and my workflow.
Would these examples, could you produce them with other technologies as well? Or are they just by chance 3D printed? So you could have used a mold making process and
well, you
bonding.
wouldn't get the surface texture. Of course, you can inject molded, you can do all SLA, SLS, whatnot, but it's cheaper to do at FDM. It's quicker and it's very beautiful.
You wouldn't get the internal weight distribution. They'd be solid.
Exactly.
They wouldn't spin, you know.
And they'd be much more expensive and they wouldn't spin and they wouldn't perform as well as they do now.
I also actually think the color distribution would be very difficult to achieve if you had to do something like that with injection molding, for example. You would need to do 2 shots or inserts, things like that, and yeah.
Absolutely, and that is one of the things that I love about 3D printing. It's, again, call it limitations, call it boundaries, but it's an opportunity to make the most of what you have, and then you get to create these shapes that are so unique, but also completely within the boundaries of this technology, and you can grow. Also brought some bags here with TPU. These are completely 3D printed on my at-home machine, and these have the same design language within the boundaries of limitations of the machine, and no one would know. I know, and I'm telling you guys.
When you mention the designer, the software, the machine, that is the point where David comes in. And for me, do modern design tools and workflow software provide the common language for designers, software engineers, and machine builders? Is it a fluently process between these 3 stages?
I mean, in most realities in companies, they're very separate, I would say. Yeah, there's like a lack of communication where maybe designers design something, then it goes to different people that will maybe manufacture 3D print prototype parts, and maybe then actually for the final manufacturing, which might not necessarily be 3D printing, it's different people again. Yeah, so I feel like their companies have difficulties to really align on design strategies, on their workflows, and yeah, that's where I think also for maybe I want to differentiate here with industrial applications. Maybe there's arts, there's architecture. We saw kind of examples from very different fields, yeah, and also it's different applications. But when I look mostly about what companies that we at Onshape work with, we look mostly at product development, yeah. But also there, companies are quite siloed, yeah. Engineers, design engineers can be really working in their own little bubble, even in their own little bubble compared to their own peers in their own teams, yeah. Because maybe the tools that they're using don't really allow for this collaborative environment. And we try to bridge that gap a little bit. We try to make design data very accessible, kind of democratize a little bit. And Onshape as a cloud-native CAD tool can do that, because I can easily give you access just by sharing your with your email address into a document. You can see my current design process, give me direct feedback on it, comment on it. And I don't know, the prototypes that we print, maybe we can take some pictures, put them directly into the document. I can see imperfections or areas maybe where the design is not currently optimized for 3D printing. And yeah, I can then iterate on that.
But don't we need a new type of software for all the different engineers, for the designers, and so on? Is it as easy what you provide, like sharing a text file? So we are working behind here in our editorial office to provide the news and so on. We are working with text files in the cloud, and it's very good because everybody has a different time and a different approach, and we need this and that. And I think it should be as easy as this for creating a new 3D object. Is it the case, or is it as easy?
Well, I guess we all learn writing at primary school, so that's probably easier to create a text document. But in terms of the sharing, the ease of access of the data, it is that easy. Yeah? So it's really everyone can be granted immediate access. We need to, of course, to understand the basics of parametric CAD modeling, and so have a foundation there. And then, of course, also increase our knowledge again to adapt it maybe to the specific or a specific additive manufacturing technology to design towards that, because also there we should be designing within the limitations. I mean, also Jonathan, he was talking about shapes, or then also he teaches a lot about SLS. SLS has a lot of design freedom, but there's things that make sense maybe to design for SLS, or where I can really bring the design to its full potential within that technology, let's say.
Would it make sense to match these services together? Would it be provide a more fluently process of designing?
I don't know. I'm maybe a bit traditional in this. All that I know about SLS, I learnt from the fact that every day for 8 years, behind my desk, behind a door, was a machine. And I saw thousands of parts come out of that. And I worked with thousands of designers who I knew what they were trying to achieve. And I knew about the materials. I knew about, so many bureaus still, have guidance on their website about how to design for SLS. And what they're talking about is minimum thicknesses, tolerances, which, is so basic and so fun and so ordinary. And all of that is a lot of that is kind of, there's a huge variation in that. And all of that is because different bureaus want to take different levels of risk. I don't want to do really, really thin things because they might fail. Therefore, I'm telling you the minimum is 0.5 millimeter. And that doesn't help anybody get the best out of the technology. So there is no... Designing for AM is like designing for anything. It's about experience, understanding materials, knowing what you're working with. And then you can start to produce objects like that, which is one piece. Yes, it was a silly book project, but, that was a £1.2 million book project in the end. Have a look on the case study archive. You'll see what that is. That is one file, one print. The actual thing, which we did 200 of, was that big. And that was only achievable because me and my team knew about SLS. You showed that to EOS. EOS looked at that and said, what machine did that?
It's very cool.
Yours.
Is this you?
It is, yes. The real book had Albert Einstein. I make no, that was a farewell present.
No, but that is completely true. You are only able to achieve such high quality and such success because you knew exactly from start to finish of this process, again, the limitations and the boundaries and the opportunities. And that's something that the 3D printing world needs.
Yeah. It's experience. And when I hear about democratization of design, I find that a bit of an insult, It's about experience and it's about learning. And, design isn't undemocratic. You just have to apply yourself. And through applying yourself, you grow, you evolve, and you have the ability to start to achieve all sorts of things.
Tobias, what's your take on that?
I'm totally with both of you. I really think even if you use Onshape, and it paves the way, the whole road where you can go all the design, engineering, production steps. I believe it has to be one person. There is no way that you have a product designer who gives the engineering away to the next step, and then the engineer says, okay, I'm done, give it into production. Like Jonathan said, you really have to understand the whole process, and there is no way around. You have to learn it. Design your own stuff, engineer your own stuff, print your own stuff, test your own stuff, and then back to A.
Yes.
No way around.
Absolutely. But do you think it's one person? In your presentation, you said it was AI.
Yeah, but for the reason that people want to design their own stuff, and you have to learn AI. But at the moment, you cannot use AI, and you really, that's the essence of what we are teaching at ID Design is the designer has to understand the technology they are designing for, and they also have to understand the engineering, and they have to test it by themselves. Even if you give it away for 3D printing, you still have to have it in your own hands, test it, and learn from it. Because this, the stretching of responsibilities, I really hate it. Because it always then ends with the designer wants something, give it to the engineer says, okay, I need more safety, I need more wall thickness, hinges doesn't work like this. Then if you load it up onto a 3D printing company website, then they have their responsibility guidelines that they don't want to build too small products, interlocking products and stuff like this. And I think you can just avoid it if you do it yourself. Buy your own 3D printer, learn to design, learn to engineer, learn to print. Mm-hmm. And then again and again and again. And it makes fun. It's really fun.
Mm-hmm. Hooking on the buzzword AI, do you use AI for your work, and which way?
I use AI for photo shoots because photo shoots are expensive, and I can just put in my bags and generate a photo shoot. I don't need a model, I don't need a photographer, I don't need a studio. I also use it for
marketing purposes, for example.
Marketing proposal, yes. And I also use it for bureaucratic contracts. Other than that, I don't use AI, not because I'm against using AI, but because I do every step of everything from start to finish, and this workflow adds to my experience and to my expertise, and it's only making me a better designer, a better engineer. So let's see.
That's because you focus very much on the creativity of your work, right? Not the outcome to have 100 of these bags, but the one bag you want to have.
Exactly. I can't make 100 bags if that one initial bag isn't perfect.
No, I mean design of 100 bags. Like in your example from the AI, where you put in your sitting room and have 100, what was it, lamps or something, or stools or whatever. So that can AI help, because it can produce a lot of designs in seconds, but that's not your approach. You want to have your creativity in the one product you produce.
Well, in my creativity, I use algorithmic design, so I don't like these two bags, the surfaces, they were created by a single algorithm, just different parameters. And I often ask myself, did I design this, or is it a collaboration with me and my algorithm, which puts me in an existential crisis, so I don't think about it that much.
You choose the final algorithm, though.
Yeah.
Right? All the input parameters that will then turn into your physical design.
Absolutely. And then I make the decision which one I like and which one will perform best when it comes to the manufacturing part of it.
Let's maybe have a quick round closing for the AI topic. Do you include AI in your products, or how do you assess the topic?
Well, I guess in my professional work at the moment, I use AI maybe to do some research, a little bit for some programming, coding, because that's a very weak spot of mine. But I was also wondering a little bit about what Tobias was talking about before, AI. Do you think AI can be a great teacher, teach us teach us also about maybe the limitations of certain technologies, teach us how we can design things to be suitable to be produced via additive manufacturing? Or you also think we should be all hands-on from the design, engineering, manufacturing, get our own machine, like always, all the time? Because I'm also looking at industries, you know, in industries, like really the responsibilities, it's usually they are divided. Yeah, that it's very seldom maybe some smaller research and development facilities where you can do from beginning to end, but otherwise responsibilities will usually be split, and we still need to make sure that companies can collaborate efficiently and produce the perfect product in the end.
At the moment, I wouldn't recommend to use AI as a teacher in general. It doesn't matter what subject, because they are so unreliable. Like failure rate is 40–50%, even with the newest models. So the only area where I would use it is inspiration. Does the AI have a new idea, can show me, for example, on these handbags, if I want to try out a new pattern for the surface, I can really easily adjust this in AI. But in the end, you really should do the design process still by yourself, 3D printed, and learn from it. So no, I wouldn't use AI more than an inspiration.
Yeah. Because I would be a lot more optimistic there. Just go nuts, I would think, you know. Try to use AI as much as you can to get some research. Teach me about the technology. Tell me what is it that I don't know yet, you know. What do I need to learn? What do I need to consider? In the future, I could also see that even more so, like more like in an agentic way, right? I create my design and then I ask AI, does this design make sense maybe for SLS printing, or what are the things that I'm not currently considering, or where I could run into some issues there?
Yeah, but there you have the problem, because you're asking AI for advice, then they will give it to you, for example, increase the wall thickness, change the angle, stuff like this.
But maybe AI has seen this example of Jonathan and think, wow, that's crazy, I can do this.
Yeah, true, but you still have the problem that the advice is 40% wrong. It's really, I would recommend it to use it only as advice.
I'm with you entirely, Tobias. I have to intervene here. We are years away from AI doing anything like what David suggests. There is not the human intelligence which for the AI to build upon yet. That is the whole reason. I mean, I'm not just doing this to advertise the additive companion, but people have looked at that and said, oh, Jonathan, AI could have put that together. Are you kidding? Are you kidding me? It can differentiate between LPBF and MJF and all of these things, and what materials they are and what they feel like and what they've been applied for and who provides them in Darmstadt. You know, it's
and on a very reliable base.
Yeah,
that is the question.
All AI will do, I mean, that frightens me, is if AI is applied to AM right now, all it's going to do is recycle the very limited received wisdom that everybody is banging their heads against. Please leave AI alone for the time being. Wait until it's digested the additive companion.
Then I challenge you again here. Your website is live today, right?
Yeah.
I can ask an AI large language model if I'm planning to do something with some constraints. Pick the best.
Don't you dare.
Pick the best of Jonathan's examples here to produce my product, for example.
But well, you know, we hope to incorporate some AI into this, as isn't perfect, as I suggested. On every page, there is the opportunity for you to tell me that's wrong or that's missing, and we want that to go in, to get that to be as strong and as definitive as possible, so that we all as humans can get going on it now.
Can I add a practical example of AI in AM, just because it's getting a bad rep? Failure detection. It's great. It's a great use in both in large-scale and small-scale additive manufacturing. That loop, it's one of the best implementations of AI in this industry, and I think, yes, of course, it's scary. And, there's a lot of discussion around that side of AI implementation that Jonathan was saying. But I do love a good failure detection.
Sophia, I'm not scared of it. It's just bad.
Yeah.
Yeah.
But I think the reason why it's bad is because AI is trained on data. And AM is mostly based on 3D models and so mostly based on data. So it's okay to use it for this. But as soon as it hits reality and we start 3D printing it, that's where the problem begins, because AI doesn't live in real space like we do. It doesn't produce in reality. If I write on a web page that I can amazingly print with 1.2 millimeter metal parts, it believes it. It doesn't have experience with failure rates. How often do you fail with it?
Some people believe
How long it will take to make
exactly.
200? How
Exactly.
much it will cost to make 200? Miles away.
There's no good feedback loop at the moment, I guess.
Yeah.
But there can be. There's so
There
much
can be, for
data
sure,
in
yeah.
3D printing software. I mean, that's all it is, right?
It's all about the training data, yeah.
Yeah, so you need like the connection between the cameras that are surveillancing the 3D printing process, so that the AI can learn from these cameras, okay, at that moment it failed, and I have to adjust my whole model because I have
So
now
a
a
very
connection to
specific
reality.
model of
Yeah.
AI.
Yeah.
I mean, yeah, there's going to be probabilities and random probabilities as well there. I mean, also there with FDM printing, now we can do, there's going to be some effects that the heat of the nozzle will have on the print quality. We can simulate that now, and it's most of the time it will not be based just on the actual physics simulation, but on AI simulation.
Yeah, and those are very practical uses that make these process and this industry that much more advanced.
Let's shift a little bit. We have some minutes left, so we might discuss a different topic. I want to shift to the idea or to the option in getting let's say the normal consumer a little bit closer to additive manufacturing and or 3D printing, and I think the topic design is big because we always have the design. It looks good and it has a good structure, and that are both topics for the consumer out there. How can we accelerate the growth in the direction of getting more consumers? I want to start with you, Sophia. What would be your approach?
My approach is making things pretty, because as funny and silly as it sounds, people are drawn to beautiful objects. And for my example, I mean, I love fashion, I love accessories. I use these bags every day, not because I made them, but because they work. Well, especially this one, it fits a lot. I have a pool bag. And because it becomes that much more approachable. I was just talking to a person in one of the booths here, and he said a term that I didn't understand, and I felt so out of the loop. And he was like, oh, it's just another word for SLA printing. I don't know when they changed it. And I think this is one of the issues that we have. We come up with all these industry difficult terms that make people scared of 3D printing because it seems so much more difficult than it actually is. And I think making approachable products, using approachable words, being fun, silly, playful, are all the things that can get consumers closer to this technology.
When you are educating, I think, young people, how can we attract more young people in not only buying, but that was your aspect was buying or consuming, that was my question, but how to get them more to users of additive?
I think in an educational context, 3D printing is magnificent, absolutely magnificent, because it is an activity that starts on a screen, and kids like screens, they enjoy screens, and it's an opportunity for them to be creative on a screen that ultimately ends up in something that is tangible, something that is physical, something that they feel invested in, and something that can encourage not just little boys, but little girls as well, into the into engineering, into the creative industries. It's a gateway to all of these things. I mean, at various shows in the past, I've been involved in educational little showcases, and kids will ask me, how do I get into 3D printing? And I honestly say to them, 3D printing is a gateway. You don't necessarily want to get into 3D printing. You want to be an architect. You want to be a product designer. You want to be a fashion designer. This is a gateway for you to start to explore those potential career pathways that are incredibly important to society. So, I don't want to overblow it, but it is very significant.
That's a very nice picture you're drawing here. That remembers me of Dominic. We had a visitor here, and we learned that he was a 14-year-old entrepreneur. So he has his own company. He has his own business. He printed since he was 9, and he has a big printer in his children's room. So we need more. Christmas presents as small printers for our kids, right?
Making things is incredibly valuable. And unfortunately, in the first world, over the last 50 or so years, we've lost all connection with how anything is made. And we need to understand that, especially if we're interested in the climate and sustainability. How can we recycle anything if we don't understand what anything's made of? So it's got a lot going for it in that.
We could talk for hours here. I want to have a very quick last round with just one word. I know that's difficult for you.
I'll try.
Yeah, you have to. You all held countless 3D printed samples in your hand. When you think about the first one, that one that changed your mind, that made really something with you, that impressed you most, or changed your life into getting into 3D printing, into AM. What was this? What was this example?
It was a product called Mode Clicks, which is on the app.
A laser tag where you add powder and then melt it on the fly and then CNC it afterwards. That fascinated me behind anything, because you can have the 3D printing and the high surface polishing we engineers love. So,
thank you.
An articulated lizard. It blew my mind when I first saw it, and it blew my mind that it was printed in one piece. And I was like, this is a technology, and these are joints I want to know everything about.
Where was it? Where?
It was in university.
Okay.
Yeah, someone just had an architecture school. People had 3D printers. They were printing lizards all the time, and I'd never seen one. And it was moving in a way, and it was printed one whole. It was like, I want to be doing that forever.
Okay, cool. David, you remember?
It's difficult because I feel like I was already on that journey, kind of, but because I wanted to say it was the first benchy boat that actually came off my own 3D printer. So it's tricky because I was already on the path, and I never let go of 3D printing after that because I'm still very excited, fascinated by the technology. And
but you don't remember the first experience, the first encounter.
No, I think I got curious about it before, but the first time I held a part in my hands that I actually produced, that was really powerful, So maybe also there, if someone that is kind of has never been exposed to 3D printing before, but is very curious, I don't know, go find a friend, find a maker space or whatever, and be able to print something yourself for the first time,
Or out there.
There are lots of benchies out there.
or out there in our live stream, come to Formnext here and go around and touch things.
There's free stuff everywhere.
Exactly.
Go get it.
So, you four, thank you very much for this lively discussion. It was really a pleasure having you here and sharing your insights and your examples here on stage. After we finish, I want to touch these if I am allowed. Yeah, thank
Everyone
you.
can come and touch these.
Thank you very much here at our panel and at home at our live stream for watching us and for giving us your time. We will have here a very short commercial break for you with some highlights from the fairground. And then we will have the next highlight here on stage because the expectations are rising. We will have the Formnext Awards celebrations here on stage. So make sure to stay with us and stay here with us at the stage. Thank you very much for joining us and have a good time.
Richtig große Metall-3D-Druckbauteile, wo kann man die eigentlich sehen in der Fertigung? Zum Beispiel bei Audi in Ingolstadt. Und wir sind das erste Kamerateam, das sich das anschauen darf. Hallo Herr Spindler.
Hallo Herr Blonski.
Schön, Sie kennenzulernen.
Schön, dass Sie kommen, um unser metallisches 3D-Druckzentrum zu besichtigen.
Was genau machen Sie hier mit additiver Fertigung bei Audi?
Zum einen entwickeln wir die Technologie weiter, neue Werkstoffe, zum anderen stellen wir Betriebsmittel her. Entweder, weil wir dadurch über Lifetime des Produkts, des Betriebsmittels Geld sparen oder weil wir Themen herstellen können, die anders qualitativ so gar nicht herstellbar wären.
Mhm. Spannend.
Ich führe Sie jetzt zu unserem Projektleiter, dem Herrn Bock, der Ihnen etwas zu unseren Betriebsmitteln zeigen wird.
Oh ja, sehr gerne. Freue ich mich. Hallo Martin, schön, dass du Zeit für mich hast hier im 3D-Druckzentrum. Ihr produziert ja hier Werkzeugsegmente für die Fahrzeugproduktion. Was genau produziert ihr hier?
Also ein Anwendungsfeld für die additive Fertigung sind Werkzeugsegmente für die Warmumformung. In der Warmumformung legen wir Blechplatinen mit 850 Grad Temperatur in ein Werkzeugsystem ein. Hier ist eine solche B-Säule von einem aktuellen Fahrzeugprojekt. Wir formen das innerhalb weniger Sekunden um und vergüten dieses Bauteil.
Und was hat das dann für einen Nutzen, dass ihr das mit so einer hohen Temperatur macht?
Durch das Vergüten erhalten wir Bauteile, die leicht und stabil sind. Gerade in solchen Bereichen und in solchen Fahrzeugkarosseriebauteilen ist es wichtig, dass hier Stabilität vorherrscht. Ein Beispiel. Hier habe ich dir mitgebracht, ein Demoteil in Kunststoff gedruckt, damit man das sehr genau sehen kann, wie das Bauteil hier in diesem gesamten Werkzeugsystem eingesetzt wird und hier mit konturnah geführten Kühlkanälen ausgestattet ist. Ja, diese konturnah geführten Kühlkanäle führen zu einer besseren Temperierung und zur Einhaltung geforderter mechanischer Eigenschaften des Endbauteils.
Kann ich mir das mal anschauen, wie ihr das macht?
Na klar.
Ja?
Dann komm einfach mal mit.
Okay, cool. So Martin, das ist jetzt hier eure neue Maschine also?
Ja, wir haben in Metall-3D-Druck investiert. Größerer Bauraum, Mehrlaseranlage, modular aufgebaut und mit einem hohen Automatisierungsgrad versehen. Wir wollen natürlich das ganze Thema Metall-3D-Druck weiterentwickeln. Das ist für uns jetzt die nächste Stufe. Bauteile sind in den letzten Jahren eher größer geworden von den Dimensionen. Deswegen auch hier 420 x 420 mm Bauraum. Wir wollen das Thema manuelle Einbindung des Werkers, die notwendig ist, reduzieren. Deshalb auch automatische Absaugung. Und dann auch modular die Anlage gestaltet, dass wir sie später erweitern.
Okay, und was ist mal Stichwort Kosten, weil so eine Maschine ist wahrscheinlich relativ teuer. Wie sieht es dann mit den Stückkosten aus für euch?
Teuer ist die Maschine. Wir werden jetzt im Detail untersuchen, wie sich die Stückkosten tatsächlich entwickeln. Aber ein großer Teil bleibt natürlich noch im Kostenblock. Das ist die Stützstrukturentfernung. Und das glaubt uns eigentlich keiner immer in der Branche, dass das aber ein großer Punkt ist, warum wir noch solche Gründe haben, nicht in die Serienfertigung zu gehen mit Metall-3D-Druckteilen. Und jetzt kommst du mal mit und jetzt zeige ich dir das mal, dass du das mal verstehst,
okay,
was das
ja, gut.
bedeutet.
Ja,
okay?
Dann lassen wir mal schauen.
Siehst du, Frank? Ganz schön anstrengend, ne?
Das ist schon ein harter Job, muss ich sagen.
Ja, Übung macht den Meister. Da musst du noch ein bisschen üben, glaube ich. Ja. Aber ich hätte gesagt, gehen wir mal raus, gucken uns das Formnext-Programm an, schauen mal, was es da Neues gibt.
Ja, ist es auch eine sehr, sehr gute Idee.
Ja.
Mensch, Martin, vielen Dank. Das hat wirklich heute sehr viel Spaß gemacht. Ich habe viel gelernt, aber es war auch echt anstrengend.
Ja, also war sehr schön, dass du da warst. Wir haben dir einen Einblick gegeben, wie wir additive Fertigung sehen im Metall-3D-Druck. Ja, ist ganz schön anstrengend an der einen oder anderen Stelle, braucht auch Zeit. Und ja, das ist so der Punkt, wo ich sage, da freue ich mich auf die Formnext und viele neue Themen und Lösungen, die dort gezeigt werden.
Wenn ihr noch Fragen an den Martin Bock habt oder an das 3D-Druckzentrum hier bei Audi, dann stellt sie gerne in den Kommentaren. Oder ansonsten sehen wir uns auf der Formnext in Frankfurt im November.
Joyride, a hit and run. I thought I loved you and you thought I was fun. I'm moving on down the road. Watch me as I go, watch me as I go. Should I look both ways before you cross me, baby? 'Cause I don't break for boys. I'm moving on. For miles, 67 fastback, oh, it's just my style. We're headed down the road. Just enjoy the show, watch me as I go. Should look both ways before you cross me, baby, 'cause I don't break for boys. I'm moving on.
Formnext 2025, day 3. And although Summit Celebration is already over, there's still loads going on. Come check it out. scanning, prototyping, casting, powdering, processing, and we've seen the entire process chain. But where can you actually have fun here? We'll find out. Wow, this is a big guy. I wonder where he was printed. Remove the structures with a chisel.
Good afternoon, everyone, and welcome back here at the industry stage at Formnext 2025, and welcome to all of you in the audience as well to one of the most special moments of this entire week. We celebrate the Formnext Awards 2025, and this is worth of applause, I think, right? I tell you what, this year is truly exceptional because Formnext celebrates its 10th anniversary. Imagine that. 10 years of ideas becoming real. 10 years of community. Thank you for that. Imagine that. 10 years of progress that none of us could have imagined when this journey started. A decade ago, we were still talking about what additive manufacturing might become in the future. Today, AM is no longer a promise. It is production, it is strategy, and it is impact. And the people driving that impact are exactly the people we celebrate today. The Formnext Awards honor outstanding contributions across 6 categories. The AM Ambassador Award, the Design Award, the Revolution Award, the Rookie Award, the Startup Award, and last but not least, the Sustainability Award. Together, they show the full strengths, diversity, and creativity of our AM family. Before we begin, there's a group whose work deserves special appreciation: our jury members. They have evaluated submissions from around the world. They compared ideas, they discussed the little details, and invested countless hours to ensure fairness, expertise, and quality in every single category. Big shout out for our jury, please, ladies and gentlemen. And to our jury, your dedication gives these awards their credibility and meaning. Thank you for your commitment. Thanks also to the incredible number of 4,345 votes from our public voters that underlines the perception of the Formnext Awards. Now, a warm thank you also to the organizations who make these awards possible, our award sponsors. Please give a warm hand of applause for Rennie Shaw and Fluxo Technologies. Without your support, honestly, we could not honor these achievements in such a powerful and very visible way. Thank you for helping us celebrate excellence in additive manufacturing. And of course, let us give a moment to the trophies themselves. So you can see them over here. Each one is naturally, additively manufactured, a perfect symbol of what this industry stands for. The design was created by Zuto, and the 3D printed production was realized by FKM. A beautiful demonstration of creativity, engineering, and AM craftsmanship coming together. Big applause for our two sponsors for the awards, please, ladies and gentlemen. Today, we celebrate finalists from research, startups, industry, and university, each contributing to the evolution of AM in their very own way. Thank you all for being here and for making the 10th anniversary of Formnext such a meaningful milestone. And saying that, let's begin with our first category of the day. Our first award is the AM Ambassador Award, honoring individuals who inspire, connect, and grow the global AM community. Let's have a look who have been the jurors for this category. Ladies and gentlemen, please now receive the laudation introducing the meaning and spirit of the AM Ambassador Award presented to you by Frank Jablonski.
Thank you, Sven. Thank you very much. Yeah, it's an honor for me, ladies and gentlemen, to present to you the award category AM Ambassadors. Diplomats are sometimes sent by their home countries into deserts or into remote mountain regions. Quite often they are assigned to host countries who are not exactly welcoming, or they are called in for very difficult conversations. Fortunately, none of these situations happened to our AM Ambassador candidates, but just like these political diplomats, they stand up for their technological homeland. They advocate for their technology and community in politics, in society, and very often even within their own companies. They support the progress of additive manufacturing on many different levels and across many platforms, tirelessly and often for many, many years. This award category honors people who make complex technologies understandable, explain their value, and build trust. People who accelerate innovation and who attract new talent into their industry. And those who build bridges between industry regulators and educational institutions. So what would be the best platform to encourage and praise them? Could there be a more suitable player to select them than Formnext? It's juries and especially the visitors of this fair who were able to cast their votes until this afternoon. After all, Formnext is world leading exhibition for additive manufacturing. Like our industry ambassadors, Formnext presents the innovations that shape 3D printing materials, software, post-processing, and automation. In short, the entire process chain. Here, experts from all over the world follow our ambassadors and come together to exchange ideas, to build meaningful business relationships, and to shape the future of industrial production. Ladies and gentlemen, even though we did not have to cross any deserts, fortunately, choosing from this remarkable group was far, far from easy. And selecting this year's shortlist of AM ambassadors was even more difficult. I'm sure they deserved it. Thank you.
Big applause, ladies and gentlemen, Frank Jablonski. Thank you, Frank. I would like now ask the finalists and from the jury, Irene Skibinski, to join me on stage. A big applause for the finalists and Irene. And while they are coming, let's have a look on the contribution of our finalists of the AM Ambassador Award. Please, video.
Since 2015, Adamat has been the heartbeat of Spain's additive manufacturing ecosystem, connecting people, technology, and purpose. Under the leadership of Nayara Zubizarreta, the association has united more than 100 members, from startups to global players, all the while shaping a vibrant AM community that now stands tall on the international stage. Through strategic collaborations, advocacy and European policy forums, and the creation of joint missions to Formnext, Adamat has transformed visibility into influence. Celebrating its 10th anniversary this year, Adamat embodies what true AM ambassadors do. That is, advance technology and build the communities that make progress possible. In Würzburg, SKZ, das Kunststoffzentrum, is bridging a crucial gap in the AM workforce. Together with the Chamber of Industry and Commerce, they've launched Germany's first certified industrial technician in additive manufacturing, a hands-on qualification with no academic barriers. This 2-year program combines theory and real-world application, from polymer and metal 3D printing to safety, design, and production management, empowering technicians to become true AM professionals. With 19 experts and a curriculum rooted in practical learning, SKZ is turning curiosity into competence and ensuring that the future of additive manufacturing is powered by skilled, ready talent. Innovation starts with education, and at RWTH Aachen University's DAP Institute, they're redefining how the next generation learns additive manufacturing. Through a pioneering, data-driven learning framework, the DAP team combines Industry 4.0 analytics, immersive AR and VR experiences, and real-time labor market intelligence to keep education aligned with industry needs. Students explore complex AM processes hands-on, from design for additive manufacturing to powder bed fusion, guided by simulations that bring invisible forces to life. By blending research, technology, and pedagogy, RWTH Aachen's DAP is teaching AM and shaping the way future engineers think, learn, and lead in this industry.
And now, ladies and gentlemen, it's my absolute pleasure to announce the winner of the AM Ambassador Award 2025. And the winner is Irena Heutzoth, SKZ, Kunststoffzentrum GmbH. Glückwunsch, Glückwunsch. Ladies and gentlemen, let's have a short group picture with all of you. Irena in the middle. Awesome.
Ja, gerne.
Thank you so much. It was a pleasure. Congratulations again. Big applause again, ladies and gentlemen. Awesome achievement. And I don't know how you feel, but this definitely set the standards for celebrating after receiving the award. That's for sure. So the next ones need to go with that. So we are coming to our next category, and this is the Design Award, celebrating outstanding creativity, innovation, and design excellence in additive manufacturing. Let's have a short look as who served as the jurors of this category. Please, ladies and gentlemen, now receive the laudation for the Design Award, introducing the meaning and creativity spirit of this award, presented to you by Frank Jablonski. Please, Frank.
Yeah, see you again. so fast. Yeah, ladies and gentlemen, dear guests, colleagues and friends, it's an honor for me to present the Laudatio for the Design Award. There is a sentence we hear again and again in the world of additive manufacturing, almost like a guiding mantra. Additive manufacturing is not a replacement for existing technologies, it is an invitation to think differently. And this new way of thinking begins with the design. In additive manufacturing, design is far more than the external shape of a part. Design is the key that unlocks entirely new freedoms, new thought processes, and new understanding of function. While traditional manufacturing constantly imposes constraints, additive manufacturing does something extraordinary. It removes them. Through design for AM, parts become lighter, physically of course, but also in a conceptual sense. Complexity is no longer punished, it's rewarded. Functions can be merged. Structures can be optimized. Geometries can finally be realized that for years existed only in some sketches, simulation, or in one's imagination. It is here at the intersection of creativity, engineering excellence, and digital freedom that truly innovations begins. But design in additive manufacturing also demands responsibility. It requires a deep understanding of processes, a willingness to rethink materials, and a commitment to sustainability at every step. A well-designed AM part does more than reduce weight or eliminate tooling. It saves energy, reduces resource consumption, simplifies logistics, shortens development cycles, and transforms how products are created and used. It shapes an entirely new industrial culture. And that is why we need people who are brave enough to explore this path. People who do more than draw, they envision. Who do more than optimize, they challenge. Who do more than develop components, they open doors to what is possible. Without their creativity, their curiosity, and their mastery of technology, many of the innovations we celebrate today simply would not exist. The AM Design Award honors exactly this spirit. It recognizes individuals and teams who don't simply use additive manufacturing, but actively shape it, who show how design becomes a strategic tool for higher performance, greater sustainability, more customization, and stronger competitiveness. People who inspire us and who remind us that the future of manufacturing is not only printed, it is designed. Ladies and gentlemen, it is my great pleasure to celebrate those who push the boundaries of what is possible and who show us the power that lies in design for additive manufacturing. Thank you.
Big applause. Thank you so much, Frank, for this great laudatio. I would like to ask the finalists on stage, and while you are giving them applause, let's have a look at their contribution.
From empathy to innovation, Grabit is redefining assistive design. Born from a personal story and inspired by real human need, this project combines design, technology, and sustainability to support people with hand impairments. Through 3 distinct forms, a ball, a ring, and a cone, Grabit enables rehabilitation, flexibility, and warmth therapy in everyday life. Each object is 3D printed with adaptive TPU lattice structures that respond to touch, pressure, and temperature, blending science and compassion in perfect balance. With every detail, Grabit restores independence, dignity, and joy, proving that true design begins with empathy. Precision meets performance in the IKM Flux Vaporizer, a breakthrough that redefines how we measure energy. This new LNG vaporization system uses generative design and additive manufacturing to more than double measurement accuracy in liquefied natural gas operations. Developed through collaboration between IKM, EOS, Valand, and ToffeeX, the team created a sculptural, fully self-supporting component that optimizes heat transfer and reduces material waste. Field tests at Equinor's LNG plant confirmed unprecedented stability and accuracy, setting a new standard for sustainable industrial design. The IKM Flux Vaporizer demonstrates how digital innovation can transform energy infrastructure and power a more transparent, efficient future. In Kenya, a remarkable collaboration is changing lives, one child at a time. The Limkine Foundation, together with HP and global partners, is using 3D printing to design and produce custom prosthetic sockets, each one made to fit a child's unique needs and offered completely free of charge. With HP's multi-jet fusion technology, these lightweight, durable sockets restore more than mobility. They restore confidence, dignity, and independence. Each smile, each step, tells a story of what's possible when innovation meets compassion. A symbol of how additive manufacturing can build a more inclusive and human-centered world, one child at a time.
Ladies and gentlemen, I couldn't be happier after this contributions to announce the winner of this year's Design Award. And the winner is Hochschule für Gestaltung Schwäbisch Gmünd.
Herzlichen Glückwunsch. Herzlichen Glückwunsch.
Let's have a group picture over there. Winner in the center. Big applause, ladies and gentlemen. What an achievement. Thank you so much. Yeah, keep on going. That is fantastic, by the way. So, thank you very much. We move now on to our next category. The Revolution Award, honoring breakthrough steps that transform technologies, workflows, and entire business models in AM. Before we start, let's have a close look of who have been the jurors for this category. Ladies and gentlemen, please receive the laudation introducing the meaning and transformational spirit of the Revolution Award presented to you by Jennifer Jones.
Good afternoon, everyone. I must say it's really nice in challenging times to be feeling the positive energy and celebrating AM. So thanks to my fellow judges and to Formnext for the awards. I've been asked to talk about the Revolution Awards, and that's thinking about how technologies and services can really add value to the user experience. And I was asked to speak today and reflect a little bit on the experience of being a judge and how we managed to do that. There were no arguments, but we had a very difficult job in the sense that there's so many different applications, different technological progress that we had to look at in the submissions. What we did focus on was very much the added value for the end user, many different types of users. And that really gave us pause to reflect on how we understand the commercial viability of some of these applications that we were sent. Because understanding the value to the end user is really how we try and understand commercial success and also scalability where appropriate. So I think very much the theme of Formnext at the moment is during difficult times, how we really commercialize a lot of the application in AM that we see and expand those and scale them where appropriate. So yeah, I would just like again to say thank you, and I'm really excited because the judges don't know who the final winner is until it's announced today. So I'm very interested to see who's won. Thank you.
Thank you very much, Jennifer Jones, ladies and gentlemen. Yeah, Jennifer, let's ask the finalists to join us on stage. And as they're joining, please give a warm hand of applause and let's see their contributions for the Revolution Award.
With Innov.IQ, Erofio and Angle showcase how additive manufacturing and digital injection molding are redefining modern toolmaking. Their fully 3D printed metal mold integrates conformal cooling channels and Angle's IQ clamp and IQ flow control, creating a seamless bridge between physical performance and digital precision. The results speak for themselves. Mold weight is reduced by 75%, energy savings of 30%, clamp forces reduced by 15%, and cycle times shortened by 10 seconds, all while improving sustainability and extending tool life. Even ultra-thin parts with walls as fine as 1 millimeter can now be produced efficiently and consistently. Innov.IQ is proving that when advanced engineering meets additive innovation, efficiency becomes more than a goal. It becomes the new standard. With Coratech Mythos, Imezicor introduces the world's first fully automated hybrid manufacturing system, uniting additive coating, PEM, with precision 5-axis milling and grinding. This innovation enables multi-material, multi-color dental restorations of exceptional accuracy, surface quality, and beauty. From crowns and bridges to implant frameworks, a fully digital CAD/CAM workflow minimizes manual steps, accelerates production, and delivers unmatched process reliability. With the ability to process up to 7 materials, including ceramics, composites, polymers, and zirconia, Mythos sets new benchmarks in efficiency, sustainability, and reproducibility. Scheduled for market launch in 2026, this system improves workflows. It reimagines them, bringing the next era of digital dentistry to life. Lempe Mussner Sinto is transforming foundry manufacturing with one of the fastest binder jetting systems in the world, already producing over 1,100 sand cores per day at the BMW Group. This integrated solution covers the entire process chain, from raw material preparation and printing to automated desanding, cleaning, and measurement, all monitored in real time with precision accuracy of plus or minus 0.3 millimeters. With printing speeds reaching 850 millimeters per second and the Lempe Printing Wizard software enabling flexible job management, the system delivers industrial-scale automation and consistency. By using inorganic binders and AM-optimized geometries, cast parts such as heat exchangers, e-motor housings, and water jacket cores now achieve up to 15% lower fuel consumption. This is innovation. This is industrial evolution, paving the way for a sustainable, data-driven foundry of the future.
Thank you very much to all the finalists in the Revolution Award, and it's a great pleasure for me to announce now the winner. And the winner of the Revolution Award at Formnext 2025 is Lempe Mussner Sinto GmbH.
Congratulations. Well earned.
Big applause, congratulations also from my side. Big achievement, thank you. Well, thanks to all the finalists, big applause again. Let's have a group picture, ladies and gents. Get together. Thank you so much. Yeah, ladies and gentlemen, keep up the tension where there are a lot more awards to come, and the next one is super important for us as well at the Formnext 2025. Our next category is the so-called Rookie Award, celebrating fresh thinkers, early stage innovators, and the bright new voices entering our AM landscape. Let's have a look of who are the jurors of this category. Na, alles gut? So, ladies and gentlemen, it's time to receive the laudation for the Rookie Award, introducing the meaning and its pioneering spirit. And it's presented by Sascha Schwarz, ladies and gentlemen.
Hey, welcome everyone. Good to see this big crowd in this very relevant topic, startups, the next generation being part of the solution in our industry. So for me and part of the jury, I'm really happy to present you the Rookie Awards Challenge, which is really close to my heart, my passion, what we do at TUM Venture Labs every day. We empower bold talents to start early, think big, and really want to become a part of the solution. Something our world needs today and also our industry, right? And the Rookie Award we started last year as a new track is this low barrier entry point for those entrepreneurial talents often missing in innovation ecosystems, a place where ideas cannot be challenged in a negative manner, in a positive manner, where they can discuss with domain-specific experts, get this early feedback, am I on the right track? And for us as TUM Venture Labs, where we support talents from the early phase until seed funding, we see this from daily on. It's really hard for these new talents, for these newbies to get the right feedback. And this is what the Rookie Challenge is really for. And I think I can speak for the jury when we would love to talk with the talents in a few years when they're successful, when they're more mature, and they say, hey, the Rookie Award was exactly that starting point, that journey who brought us this first step towards a successful startup. So I would say, right, let's have a look at the finalists, but I could really say, and also the jury, if this is what the next generation of startups and entrepreneurs looks like, I would say the future of AM looks really bright. Thanks a lot.
Big applause, ladies and gentlemen. Sascha Schwarz. And while we ask the finalists on stage, and please save your applause for them again, it's very important, we will have a look on their contribution. Please, the finalists of the Rookie Award.
From craftsmanship to code, Fidentis GmbH is transforming dental technology. A Fraunhofer IGCV spin-off, Fidentis has developed the world's first commercial multi-material additive manufacturing process for telescopic prosthetics. This innovation allows the fusion of precious and non-precious metal alloys like cobalt, chromium, molybdenum, and gold within a single build, achieving micrometer precision and eliminating manual adjustments. Where traditional dentures required years of expertise and labor-intensive polishing, Fidentis delivers patient-specific prosthetic frameworks with engineered friction fit built directly into the design. The result is reduced metal waste, greater consistency, and scalable digital production. By bridging CAD/CAM workflows with industrialized multi-material AM, Fidentis establishes the first fully digital chain for removable dentures, redefining precision, access, and quality in dental care. Sometimes innovation begins with the smallest breath. 3D My Mask, developed by Digifab in collaboration with the International Advanced Manufacturing 3D Hub, creates custom silicone masks for premature infants using 3D scanning and additive manufacturing. In neonatal care, one size has never fit all. Standard nasal interfaces often cause air leaks, pressure injuries, and craniofacial strain. 3D My Mask changes that by tailoring every curve to each child's unique anatomy, reducing air leakage by up to 60% and improving comfort and safety for the most fragile patients. Driven by a clinical industrial alliance that includes Hospital Clínic de Barcelona, IAM 3D Hub, and multiple technology partners, 3D My Mask shows how empathy and engineering can breathe new life into medical innovation, because even the tiniest patients deserve the best of technology from their very first breath. At Tesseract Technologies, motion itself is being re-engineered. Traditional large-format 3D printers depend on belt-driven stepper motors. Tesseract replaces belts with proprietary linear motors that glide directly over magnetic rails, eliminating transmission errors, improving speed, and ensuring consistent print quality regardless of printer size. The secret is accessibility. By designing their own motors from the ground up, Tesseract has cut costs by 5 to 10 times compared to industrial alternatives, without compromising performance. Already piloted with leading manufacturers, this technology brings industrial-grade motion control into reach for the entire 3D printing sector. With Tesseract, large-format printing is no longer a compromise. It's a new benchmark for precision, reliability, and speed.
I don't know how you feel, but I'm totally in line what was just saying, and I'm so grateful for the contribution of the finalists for the Rookie Award, and so I'm very happy to announce the winner of 2025's winner of the Rookie Award, and it's IAM 3D Hub Project 3D My Mask. Big applause, ladies and gentlemen.
Congratulations. Hey.
David, congratulations, great achievement. Thank you to both of you, thank you. Have a group pictures, all together. That's awesome, thank you so much. So, ladies and gentlemen, we are now coming to one of the most anticipated categories of the evening, the Startup Award. Honoring innovative young companies with strong business models and real industry potentials. And I'm very curious to see who the jury was for this category. Please. And I'm super happy to announce her on stage. Please receive the laudation, introducing the meaning and entrepreneurial spirit of the Startup Award, brought to you by Alex Kingsbury, please.
Thank you. Well, welcome everyone. As Sven just described, this is the most anticipated award of tonight, right? This is the field of dreams, where dreams become reality in actual companies. These companies were started by founders that had an idea that they just could not let go of. It just gnawed away at them, and they were just compelled. They had to go and do something about this. They had to stop doing what they were doing, and they had to focus on this company, create this company. And this is where we're able to bring the most incredible innovations into our industry, is through the startup companies, because this is about actually making that idea work. But it doesn't come without sacrifice. And all of these people have done incredible things and made big sacrifices to see their dreams become reality. And I think that that should be celebrated. It's really important that we appreciate the sacrifices that are made. These people are innovators and dreamers. They're a rare breed. And I'm so thankful that they're in our industry, because 3D printing was an industry of disruption itself. And what better way to introduce disruption into a disruptive industry than through startups? On behalf of the judging panel, I think I can say that we were just blown away by the amount of progress that these startups were able to make in the last 5 years, because that is the criteria, by the way. They have to be no more than 5 years old. And some of these companies, when we were reading about them, learning about them, hearing their stories, we thought these are the most mature, incredible companies. But it's important to acknowledge here that for every success, there have been multiple failures, disappointments, setbacks. And that's what I mean by these people are sacrificing a lot to get these companies and get products and ideas out into the marketplace. So, at this 10th anniversary of Formnext, the event that we unofficially call our family reunion, we celebrate our babies that will one day be, I am very, very confident of it, the next big companies of tomorrow. Thank you.
Thank you very much, Alex. Big applause for you. Excellent laudation. Thank you for that. So while we ask our finalists to the stage, and where you have to save another applause, please, let's have a look at their contributions.
Alonic is revolutionizing robotics manufacturing with 3D tissue braiding, a world-first technology that grows complex, movable robot bodies directly from functional fabrics. Using a seamless software-hardware platform, the company enables automated creation of flexible robotic structures, arms, fingers, and joints without assembly. By embedding elastic fibers, sensors, and wiring within a single 3D textile form, Alonic reduces costs, speeds up prototyping, and redefines how machines come to life. This is soft robotics, engineered with precision, where design meets biology, and the next generation of human-safe automation begins. BioMotion is transforming life sciences with industrial-grade 3D bioprinting, making it as reliable and accessible as modern manufacturing. Their high-precision platform integrates automated parameter control and intelligent supervision to ensure reproducible results. Every single print, every single time. This innovation empowers pharmaceutical and biotech companies to replace traditional 2D cell cultures with 3D human tissue models, accelerating drug discovery while eliminating the need for animal testing. By bridging biology and industry, BioMotion is enabling scalable, ethical, and data-driven medical research for the next generation of therapies. Nurio is unlocking new speed and creativity in engineering design. Their AI-driven 3D software tools automate repetitive CAD tasks and generate production-ready designs for additive manufacturing within minutes. By capturing expert logic into code, Nurio's plugins and online configurators drastically reduce design cycles, improve manufacturability, and cut costs. From aerospace to tooling, they are helping engineers move from manual modeling to intelligent automation, transforming the design process from constraint to catalyst. Osseo Labs combines AI, 3D printing, and bioresorbable materials to create personalized implants that heal naturally within the body. Their Osseo Vision and Osseo Matrix platforms enable patient-specific orthopedic and facial implants, already validated in more than 250 clinical cases. By using 3D printed magnesium scaffolds that safely dissolve as bone regenerates, Osseo Labs reduces surgical time, improves recovery, and minimizes the need for follow-up operations. It's precision medicine engineered through additive manufacturing, designed for healing and powered by AI. Perfy Technologies is pioneering volumetric additive manufacturing, a game-changing process that prints complete 3D parts in seconds, not hours. By projecting light patterns into a rotating vat of resin, their system forms entire objects in one go, eliminating layers, supports, and waste. The compact desktop unit enables on-demand, point-of-care production for customized medical and dental devices, with a closed-loop resin recovery system for sustainability. Fast, precise, and solvent-free, Perfy is redefining what's possible in high-speed, sustainable 3D printing.
Ladies and gentlemen, in order to follow the laudation of Alex Kingsbury, we will see now who has the biggest booth at Formnext 2035. Let me announce the winner of the Startup Award, and the winner is Perfi Technology.
Congratulations! Well done, it's fantastic.
Oh, you can do that as well, Alex.
Thank you. I got a big check for you.
Awesome. Let's have a fantastic group picture. Take her in the middle. Alex, will you join them? Well deserved. Big applause, ladies and gentlemen. Thank you, Alex. Thank you to the finalists. Big contribution. Thank you so much. Thank you, Alex. And now, ladies and gentlemen, we are arriving at our final category of today's ceremony. The Sustainability Award, celebrating solutions that reduce waste, optimize resources, and drive environmental responsibility through additive manufacturing. And I'm very curious to see who the jurors are for the Sustainability Award. Please, ladies and gentlemen. Rainer, it's a pleasure to see you. Good to have you.
Hello.
Ladies and gentlemen, please now receive the laudation. Introducing the meaning and sustainable vision of the Sustainability Award, presented by the category sponsor, Rainer Lotz from Renishaw. Big applause, ladies and gentlemen.
Thank you very much. As we just heard, sustainability is essential to adapt to environmental and social challenges we're all facing. It helps to mitigate risks and it creates long-term value by balancing economic, social, and environmental goals. Sounds nice. What does it mean in production? For us in Renishaw, sustainability is a very vital part of our company DNA, of our values we live. And of course, sustainability important to everyone within the people, the organization. It's very important for us in our own factory, and it's very important to us in our product design and in our product development. If we look in general in productions with industrial metrology products we have, or with position measurement products we reduce scrap. So we reduce the use of material, we reduce the consumption of energy. So we reduce the carbon footprint of a factory, which makes everything more cost effective and sustainable. And it's, at the end, it's an economic value. When we look at additive manufacturing, it's obviously more sustainable for particular product designs where I use less material, but also when we look at the systems, at our systems, we can see a system where we have more reuse of reactive materials. They can be quite expensive, like metal grade titanium and so on. But also small footprints of the systems, also small energy consumption, but also nowadays software in machines where you can reduce support structures over 90%, which again is less material, less energy. It's more sustainable in the production. If we look at it, sustainability is an economic value which can and should lead within a company to more competitiveness. And I would say today sustainability can be an ingredient, especially for companies in Europe, to increase their competitiveness. And therefore, I hope that this award leads to the effect that sustainability is more recognized as economic value, and I'm very curious who the winner will be.
Thank you so much, Rainer Lotz, ladies and gentlemen. And I will now ask the finalist and our jury member, Sherry Monroe, to the stage. Please join us here. And while that, big applause for them, please. We look at the contributions of this year's Sustainability Award. Please.
At Continuum Powders, sustainability isn't an afterthought, it's the mission. The company is revolutionizing metal powder production by recycling certified aerospace waste into high-quality, application-ready alloys. Using its proprietary Greyhound melt-to-powder M2P platform, Continuum transforms scrap materials like nickel, titanium, and cobalt into premium powders that match and often exceed the performance of virgin materials. A life cycle study by Oregon State University revealed a staggering 99.7% reduction in greenhouse gas emissions, making this one of the cleanest powder production processes in the world. With its OptiVantage quality framework, Continuum ensures each batch meets aerospace-grade standards, proving that circularity and precision can coexist. From binder jetting to laser powder bed fusion, their powders are already powering the next generation of sustainable manufacturing, where waste becomes value and performance drives responsibility. EOS has reimagined the environmental footprint of metal additive manufacturing, starting with what's usually overlooked: waste. During every print, reactive byproducts like condensate and soot are formed, microscopic, hazardous, and costly to dispose of. EO's new next-generation filtration system turns this challenge into an opportunity. It neutralizes reactive particles within the process, transforming them into stable, recyclable metal oxides, all without chemicals or external passivation agents. At the same time, reusable powder is recovered, reducing material loss and cutting emissions by more than 90%. The result? Cleaner production, safer disposal, and a closed-loop filtration cycle that's both economically and environmentally sustainable. EOS is proving that innovation in additive manufacturing doesn't just mean building smarter machines, it means designing for a smarter planet. From the heart of southern Spain, Smart Materials 3D is turning everyday organic waste into extraordinary 3D printing materials, redefining what sustainability looks like in additive manufacturing. Their journey began with olive, the world's first 3D printing filament made from olive pits, a byproduct of Spain's thriving olive oil industry. What started as a regional experiment has evolved into a global sustainability model. Through their SmartFill Eco line, Smart Materials 3D transforms locally sourced organic waste, from oyster shells and pine wood to cork, coffee, and algae, into high-performance biodegradable filaments and pellets. These bio-based materials not only reduce virgin plastic use and carbon footprint, but also preserve natural aesthetics, producing filaments that look, feel, and perform beautifully across both desktop and large-format 3D printers. Certified under ISO 9001, ISO 14001, REACH, and PEFC, Smart Materials 3D stands as proof that sustainable innovation can be both scientifically sound and artistically inspiring. Smart Materials 3D proudly showcases that innovation made in Spain isn't just advanced, it's responsible, renewable, and ready for the world.
And ladies and gentlemen, as I know how much focus Formnext puts on sustainability, and I'm super happy that companies like Renishaw acknowledge especially these contributions, I'm more than happy to announce the winner of 2025's winner of the Sustainability Award, which is EOS GmbH Electrical Systems. Awesome. Let's have a group picture. Awesome, guys. Thank you very much. Big applause again for them. We'll see us later for the big finalist group picture, ladies and gentlemen. Ladies and gentlemen, please stay here because before we close the award ceremony, I want to talk, as we have the 10th anniversary of Formnext, to 4 very responsible persons having to do with the evening here and talk to them. What is the meaning and the power of the Formnext Award in the context of 10 years Formnext? Please welcome with me President of Misago, Petra Harburger on stage, followed by Sascha Wenzler, Vice President Formnext. Please, Sascha. Christoph Stücker, as well, Vice President of Formnext, and our main sponsor and category sponsor, Rainer Lotz from Renishore, ladies and gentlemen. Yeah, have a group picture. No, I let you do that. Fair enough. So let me ask you a few questions. Petra, it's so good to see you.
Good to see you.
Thank you so much. Petra, let's put that into perspective, not only about the 10 years, but why are these Formnext Awards so important for Formnext?
I just think that it mirrors the variety and the depth of what AM can do. And I think this is what we also saw on the show floor. It's so amazing what's been done. And for me, I'm so proud also to see how much effort and what did she said, how deep the roots are from some of them. So I think for me, it just mirrors everything. And yeah, we're just really proud. I'm really proud of the team who did all this.
Thank you, Petra. Sascha, Alex was talking about sacrifices, and I know you do a lot of sacrifice as well in order to set up this fantastic show. As we celebrate 10 years and looking at the awards, how much do they reflect the evolution over time of the 10 years from Next? What would you say?
Oh, that's totally unusual for me. I can keep this very short. It's showing really the pure excellency additive manufacturing has reached in these 10 years, and that's reflected by the award winners, by the technologies behind, by the use cases behind. It's excellence, pure excellence.
Awesome. Rainer, I mean, you are not only the main sponsor of the event, you're also a category sponsor, so you put a special focus on sustainability as well. So give us a little bit your feedback. What surprised you or what impressed you most about this year's finalists and the contribution they brought?
Well, I would say that the width of the variation of solutions we're seeing here, and I think it's actually quite a reference to the whole show that we see far more applications and products coming out of the industry now, and also the award reflects this. For me, when I look at the last 10 years Formnext, I would say the award is a bit the cherry on the top of the whole thing, obviously showing the very smart solutions, but it's the variety. And so I hope also that they came second or third, or they have been in the closer loop of it. They shouldn't be too disappointed. They should be proud. And it's nice to acknowledge these solutions from these companies.
And if I may add that, if you see the number of public votes, and I see the progress over years, it's congrats to you, by the way, or applause for you. It's amazing to see how this has been evolving. Absolutely. So that we can all see how important this is for all of us to acknowledge the achievements. Christoph, I know that you sometimes, or you do it, of course, for a purpose, you get feedback. And my question to you would be, what does winning a Formnext award from the feedback you get mean for these companies? If you don't get feedback, let's say your impression on that.
No, I'm pretty sure that we get some very positive feedback from our finalists as well as the winners. The winners, of course, are in the spotlight, but so are the finalists who really show fantastic excellence in additive manufacturing, in manufacturing overall. And a heartfelt congratulations to all the winners and the finalists. As you said, Rainer, I think all of them put a real great effort into it. And I would say, similar to our anniversary today, it's a big family celebration, and some family members are a bit further ahead in the journey. Some are right at the beginning. We are now maybe, well, may I say this, a little bit of dinosaurs?
Well,
with
I
10
think
years?
you're not. You're not
For sure,
No.
but equally, we will all celebrate together today with all of you. So you're kindly invited, and yeah. So congratulations again to all.
And I want to add one thing, because I think if you look at the joy and this passion that we've seen here on stage from the winners and from the others, it's so rewarding somehow as well. And it's so wonderful, because I think it really shows also the passion that everybody brings into this technology. And I think this is just really cool. It's really worth everything.
And if I'm allowed to do so, even as a moderator, to give a feedback on that, I mean, those startups or those companies you have usually in pitches or in panel discussions, and it's so satisfying to see them being rewarded for what they contribute to our industry, even as a moderator, because it really shows how we develop and getting faster. Sasha, as Christoph already assigned you as the dinosaur in this round, let me ask you a rather historic question. Thinking about inventing the Formnext Awards, when did we start with the Formnext Award, and how has that been evolving over the years?
Oh, that's not a dinosaur. We now have the awards in the second year. So,
okay.
Yeah, but that's also perfectly reflecting the development in the last years. So now we have this culmination of bright minds, like we call them, bringing together and rewarding them. And I think that's also honoring this dedication to the topic. So again, thank you very much. And yeah, you're driving the family forward. You see, I wear the T-shirt already. Yeah, so thank you very much. Congratulations to you guys. You contribute so much, and you bring the technology forward for us dinosaurs a little bit.
You're looking at me, I realize.
No, we won't clear that topic anymore. Yeah. So, I mean, please give a warm applause for the dinosaurs of Formnext. Thank you so much. It was a pleasure to have all four of you here. Thank you for your contribution. Thank you for making this possible. It's really a great honor to serve you. Thank you so much. Ladies and gentlemen, please. So, yeah, for you at home at the stream, I hope you enjoyed it as much as I did, the excitement of the winners and the finalists. And I'm really impressed what we brought together this year. And I'm so much looking forward what waits for us in the future of additive manufacturing. And one thing is for sure, you will see it here at Formnext in Frankfurt. Thank you so much. Enjoy your evening, and goodbye. See you tomorrow.
Oh, come on, Lisa. Shut up. This is ridiculous.
So, what have we got so far? Any brilliant ideas for the anniversary?
People, program, process, popcorn, and party.
Pole dance.
Professionalism.
We show people. Professional people.
Smiling people? No, please. Not just a parade of happy faces.
People,
Talking about where they're from.
No time for that. And how does that connect to additive manufacturing?
Right. Because they're holding something. A part. A cool design. Something 3D printed.
Let's hope your enthusiasm can save the pitch at 11. We'll need all of it.
Let's show the products. Think of commercials for car porn style. This is gonna be hot.
Why not add some bad taste erotic music?
Let's not.
Yeah, let's not.
This project is killing me. It has to be something special.
Something special, something specific, specific industries.
Aviation and aerospace, lightweight is important to them. Engineering and construction, definitely big ones in 3D printing. They'd love to see that too. And jewelry is on the rise. They sure expect more visitors from this sector. Don't even think about bringing up Paul.
But he was the secret star of the last exhibition.
Still can't believe it.
What about the faces behind Formnext, the organizing team? We have event management, sales and customer care, marketing and communication.
Exhibitor services, new sales, and the management. With Christoph, Sasha, and of course, Petra. Though I can already hear her say, I don't think this is gonna work that way.
Can we cover the entire process chain?
The entire process chain?
The entire process chain.
Epic film.
An epic film with huge machines and massive booths.
In slow motion.
Awesome.
Awesome. Awesome. Awesome.
That's literally every other trade show video.
Let's break expectations and we finally deliver something truly fresh. We show how AM works in production.
Done that already. Application Insight at Audi 2023.
Or we show the unique benefits of 3D printed parts made of special materials.
Done that already. Technical Ceramics, Exhibitor Focus 2024.
Or we dive into different 3D printing technologies.
SLS and SLA Technology, Exhibitor Spotlight 2022. Done that already.
Done that already.
Yeah, we do that every year. We need to nail this. We need to deliver something truly special.
So what do you suggest?
How about we finish with a conga line?
Oh, come on, Lisa. Shut up. This is ridiculous.
Woke up this morning. Now watch me step. The week was murder. I'm gonna get rid of the stress.